lecture. Most people think hackers have extraordinary skill and knowledge that allow them to hack into computer systems and find valuable information. The term hacker conjures up images of a young computer who types a few commands at a computer screen and proof the computer spits out passwords, account numbers, or other confidential data. In reality, a good hacker or security professional acting as an ethical hacker just has to understand how a computer system works and know what tools to employ in order to find a security weakness. This lecture will teach you the same techniques and software tools that many hackers use to gather valuable data and attack computer systems. The realm of hackers and how they operate is unknown to most computer and security professionals. Hackers use specialized computer software tools to gain access to information. By learning the same skill and employing the software tools used by hacker, you will be able to defend your computer networks and system against malicious attacks. The goal of this first lecture is to introduce you to the world of the hacker and to define the terminology used in discussing computer security. To be able to defend against malicious hacker, security professionals must first understand how to employ ethical hacking techniques. This lecture will detail the tools and techniques used by hackers so that you can use those tools to identify potential risk in your computer system. This lecture will guide you through the hacking process as a good guy. Most ethical hackers are in the business of hacking for profit, an activity known as penetration testing or pen testing for short. Pen testing is usually conducted by a security professional to identify security risks and vulnerabilities in systems and networks. The purpose of identifying risks and vulnerabilities is so that a countermeasure can be put in place and the risk mitigated to some degree. Ethical hackers are in the business of hacking and as such need to conduct themselves in a professional manner. Additionally, state, country or international laws must be understood and carefully considered prior to using hacking software and techniques. Staying within the law is a must for the ethical hacker. An ethical hacker is acting as a security professional when performing pen tests and must always act in a professional manner. Defining ethical hacking. The next section will explain the purpose of ethical hacking and exactly what ethical hackers do. As mentioned earlier, ethical hackers must always act in a professional manner to differentiate themselves from malicious hackers, gaining the trust of the client and taking all precautions to do no harm to their systems during a pen test are critical to being a professional. Another key component of ethical hacking is to always gain permission from the data owner prior to accessing the computer system. This is one of the ways ethical hackers can overcome the stereotype of hackers and gain the trust of clients. The goal ethical hackers are trying to achieve in their hacking attempts will be explained later. Understanding the purpose of ethical hacking. When I tell people that I am an ethical hacker, I usually hear sneakers and comments like that's an oxymoron. Many people ask, can hacking be ethical? Yes, that best describes what I do as a security professional. I use the same software tools and techniques as malicious hackers to find the security weakness in computer network and systems. Then I apply the necessary fix or patch to prevent the malicious hacker from gaining access to the data. This is a never-ending cycle as new weaknesses are constantly being discovered in computer systems and patches are created by the software vendors to mitigate the risk of attacks. Ethical hackers are usually security professionals or network penetration testers who use their hacking skills and tool sets for defensive and protective purposes. Ethical hackers who are security professionals test their network and system security for vulnerabilities using the same tools that a hacker might use to compromise the network. Any computer professional can learn the skill of ethical hacking. The term cracker describes a hacker who uses their hacking skills and toolset for destructive or offensive purposes such as disseminating viruses or performing denial of services attacks to compromise or bring down systems and network. No longer just looking for fun, these hackers are sometimes paid to damage corporate reputations or steal or reveal credit card information while slowing business processes and compromising the integrity of the organization. White hats. White hats are the good guys, the ethical hackers who use their hacking skills for defensive purposes. White hat hackers are usually security professionals with knowledge of hacking and the hacker toolset, and who use this knowledge to locate weakness and implement countermeasures. White hat hackers are prime candidates for the exam. White hats are those who hack with permission from the data owner. It is critical to get permission prior to the beginning any hacking activity. This is what makes a security professional a white hat versus a malicious hacker who cannot be trusted. Black hats. Black hats are the bad guys, the malicious hackers or crackers who use their skills for illegal or malicious purposes. They break into or otherwise violate the system integrity of remote systems with malicious intent. Having gained unauthorized access, black hat hackers destroy vital data, deny legitimate user service, and just cause problems for their targets. Black hat hackers and crackers can easily be differentiated from white hat hackers because their actions are malicious. This is the traditional definition of a hacker and what most people consider a hacker to be. Grey hats. Grey hats are hackers who may work offensive or defensively depending on the situation. This is the dividing line between hacker and cracker. Grey hat hackers may just be interested in hacking tools and technologies and are not malicious black hats. Grey hats are self-proclaimed ethical hackers who are interested in hacker tools mostly from a curiosity standpoint. They may want to highlight security problems in a system or educate victims so they secure their systems properly. These hackers are doing their victims a favor. For instance, if a weakness is discovered in a service offered by an investment bank, the hacker is doing the bank a favor by giving the bank a chance to rectify the vulnerability. From a more controversial point of view, some people consider the act of hacking itself to be unethical, like breaking and entering, but the belief that ethical hacking excludes destruction at least moderates the behavior of people who see themselves as benign hackers. According to this view, it may be one of the highest forms of hackerly courtesy to break into a system and then explain to the system operator exactly how it was done and how the hole can be plugged. The hacker is acting as an unpaid and unsolicited team. This approach has gotten many ethical hackers in legal trouble. Make sure you know the law and your legal liabilities when engaging in ethical hacking activity. The difference between white hats and grey hats is that permission word. Although grey hats might have good intention, without the correct permission, they can no longer be considered ethical. Hello everyone, welcome to my lecture, The Way of the Program. The goal of this lecture is to reach you to think like a computer scientist. This way of thinking combines some of the best features of mathematics, engineering, and natural science. Like mathematicians, computer scientists use formal language to denote ideas. Like engineers, they design things, assembling components into systems and evaluating trade-offs among alternatives. Like scientists, they observe the behavior of complex systems from hypothesis and test prediction. The single most important skill for a computer scientist is problem solving. Problem solving means the ability to formulate problems, think creatively about solutions, and express a solution clearly and accurately. As it turns out, the process of learning to program is an excellent opportunity to practice problem solving skills. That's why this lecture is called the way of program, the Python programming language. The programming language you will learn is Python. Python is an example of a high level language. Other high level language you might have heard of are C, C++, Perl and Java. There are also low level languages, sometimes referred to as machine languages or assembly languages. Loosely speaking, computers can only execute programs written in low level language. So programs written in a high level language have to be processed before they can run. This extra processing takes some time, which is a small disadvantage of high level languages. The advantages are enormous. First, it is much easier to program in a high level language. Programs written in a high level language take less time to write. They are shorter and easier to read, and they are more likely to be correct. Second, high level languages are portable, meaning that they can run on different kinds of computers with few or no modifications. Low level programs can run on only one kind of computer and have to be rewritten to run on another. Due to these advantages, almost all programs are written in high level languages. Low level languages are used only for a few specialized applications. Two kinds of programs process high level languages into low level languages: interpreters and compilers. An interpreter reads a high level program and executes it, meaning that it does what program says. It processes the program a little at a time, alternately reading lines and performing computations. A compiler reads the program and translates it completely before the program starts running. In this context, the high-level program is called the source code, and the translated program is called the object code or the executable. Once a program is compiled, you can execute it repeatedly without further translation. Python is considered an interpreted language because Python programs are executed by an interpreter. There are two ways to use this interpreter: interactive mode and script mode. In interactive mode, you type Python programs and the interpreter prints the result 1 plus 1, 2. The chevron is the prompt in the interpreter uses to indicate that it is ready. If you type 1 plus 1, the interpreter replies 2. Alternatively, you can store code in a file and use the interpreter to execute the contents of the file, which is called a script. By convention, Python scripts have names that end with py. To execute the script, you have to tell the interpreter the name of the file. In a Unix command window, you would type python dinsaddle.py. In other development environments, the details of executing scripts are different. You can find instructions for your environment at the Python website python.org. Working in interactive mode is convenient for testing small pieces of code because you can type and execute them immediately. But for anything more than a few lines, you should save your code as a script so you can modify and execute it in the future. What is a program? A program is a sequence of instructions that specifies how to perform a computation. The computation might be something mathematical, such as solving a system of equations or finding the roots of a polynomial, but it can also be a symbolic computation, such as searching and replacing text in a document or compiling a program. The details look different in different languages, but a few basic instructions appear in just about every language. Input: get data from the keyboard, a file or some other device. Output: display the data on the screen or send data to a file or other service. Math: perform basic mathematical operations like addition and multiplication. Conditional execution: check for certain condition and execute the appropriate sequence. Statements. Repetition. Perform some actions repeatedly, usually with some variation. Believe it or not, that's pretty much all there is to it. Every program you have ever used, no matter how complicated, is made up with instructions that look pretty much like this. So you can think of programming as the process of breaking a large, complex task into smaller and smaller subtasks until the subtasks are simple enough to be performed with one of these basic instructions. They may be a little vague, but we will come back to this topic when we talk about algorithms. What is debugging? Programming is error prone. For whimsical reasons, programming errors are called bugs, and the process of tracking them down is called debugging. Three kinds of error can occur in a program: syntax error, runtime errors, and semantic errors. It is useful to distinguish between them in order to track them down more quickly. What is debugging? Programming is error prone. For whimsical reasons, programming errors are called bugs, and the process of tracking them down is called debugging. Three kinds of errors can occur in a program: syntax error, runtime errors, and semantic errors. It is useful to distinguish between them in order to track them down more quickly. Syntax errors. Python can only execute a program if the syntax is correct. Otherwise, the interpreter displays an error message. Syntax refers to the structure of a program and the rules about the structure. Runtime errors. The second type of error is a runtime error, so called because the error does not appear until after the program has started running. These errors are also called exceptions because they usually indicate that something exceptional has happened. Runtime errors are rare in the simple programs you will see in the first few, so it might be a while before you encounter one. Semantic errors. The third type of errors is the semantic error. If there is a semantic error in your program, it will run successfully in the sense that the computer will not generate any error messages, but it will not do the right thing. It will do something else. Specifically, it will do what you told it to do. The problem is that the program you wrote is not the program you wanted to write. The meaning of the program is wrong. Identifying semantic errors can be tricky because it requires you to work backward by looking at the output of the program and trying to figure out what is it doing. Thank you. Hello everyone, welcome to my lecture. Vulnerability scanning. Vulnerability scanning is the process of proactively identifying the vulnerability of computer system on a network. Generally, a vulnerability scanner first identifies the operating system and version number, including service packs that may be installed. Then the scanner identifies weaknesses or vulnerabilities in the operating system. During the later attack phase, a hacker can exploit those weaknesses in order to gain access to the system. Although scanning can quickly identify which hosts are listening and active on a network, it is also a quick way to be identified by an intrusion detection system. Scanning tools probe TCP/IP ports, looking for open ports and IP addresses, and these probes can be recognized by most security intrusion detection tools. Network and vulnerability scanning can usually be detected as well, because the scanner must interact with the target system over the network. Depending on the type of scanning application and the speed of the scan, an IDS will detect the scanning and flag it as an IDS event. Some of the tools for scanning have different modes to attempt to defeat an IDS and are more likely to be able to scan undetected. As a CEH, it is your job to gather as much information as possible and try and remain undetected. The CEH scanning methodology. As a CEH, you are expected to be familiar with the scanning methodology presented below. This methodology is the process by which a hacker scans the network. It ensures that no system or vulnerability is overlooked, and that the hacker gathers all necessary information to perform an attack. We will look at the various stages of this scanning methodology throughout this lecture, starting with the first three steps: checking for systems that are live and for open ports and service identification. Ping swap techniques. The CEH scanning methodology starts with checking for systems that are live on the network, meaning that they respond to probes or connection requests. The simplest, although not necessarily the most accurate, way to determine whether systems are live is to perform a ping sweep of the IP address range. All systems that respond with a ping reply are considered live on the network. A ping swap is also known as Internet Control Message Protocol scanning, as ICMP is the protocol used by the ping command. ICMP scanning or a ping swap is the process of sending an ICMP request or ping to all hosts on the network to determine which ones are up and responding to pings. ICMP began as a protocol used to send test and error messages between hosts on the network. On the internet, it has evolved as a protocol utilized by every operating system, router, switch, or internet protocol based device. The ability to use the ICMP echo request and echo reply as a connectivity test between hosts is built into every IP enabled device via the ping command. It is a quick and dirty test to see if two hosts have connectivity and is used extensively for troubleshooting. A benefit of ICMP scanning is that it can be run in parallel, meaning all systems are scanned at the same time. Thus, it can run quickly on an entire network. Most hacking tools include a ping sweep option, which essentially means performing an ICMP request to every host on the network. Systems that respond with a ping response are alive and listening on the network. Perform a ping sweep using built-in Windows tools. One considerable problem with this method is that personal firewall software and network-based firewalls can block a system from responding to ping sweeps. More and more systems are configured with firewall software and will block the ping attempt and notify the user that a scanning program is running on the network. Another problem is that the computer must be on to be scanned. Thank you. Hello everyone, welcome to my lecture. Sniffers. A sniffer is a packet capturing or frame capturing tool. It basically captures and displays the data as it is being transmitted from host to host on the network. Generally, a sniffer intercepts traffic on the network and displays it in either a command line or GUI format for a hacker to view. Most sniffers displays both the layer 2 or layer 3 headers and the data payload. Some sophisticated sniffers interpret the packets and can reassemble the packet stream into the original data, such as an email or a document. Sniffers are used to capture traffic sent between two systems, but they can also provide a lot of other information. Depending on how the sniffer is used and the security measures in a place, a hacker can use a sniffer to discover usernames, passwords, and other confidential information transmitted on the network. Several hacking attacks and various hacking tools require the use of a sniffer to obtain important information sent from the target system. This lecture will describe how sniffers work and identify the most common sniffer hacking tools. Remember, the term packet refers to the data at layer 3 or the network layer of the OSI model, whereas frame refers to data at layer 2 or the data link layer. Frames contain MAC addresses and packets contain IP addresses. Understanding host-to-host communication. All host-to-host network communication is based upon the TCP/IP data communication model. The TCP/IP model is a 4-layer model. The TCP/IP model maps to the older OSI model with 7 layers of data communication. Most applications use the TCP/IP suite for host-to-host data communication. In normal network operations, the application layer data is encapsulated and a header containing address information is added to the beginning of the data. An IP header containing source and destination IP address are added to the data, as well as a MAC header containing source and destination MAC addresses. IP addresses are used to route traffic to the appropriate IP network, and the MAC addresses ensure the data is sent to the correct host on the destination IP network. In this manner, traffic is sent from source host to destination host across the internet, and delivery to the correct host is ensured. The postal system works much the same way. Mail is routed to the appropriate area using the zip code, and then the mail is delivered within the zip code to the street and house number. The IP address is similar to the zip code to deliver mail to the regional area, and the street and house numbers are like the MAC address of that exact station on the network. TCP/IP model are shown below. The address system ensures accurate delivery to the receiver. In normal network operations, a host should not receive data intended for another host, as the data packet should only be received by the intended receiver. Simply said, the data should only be received by the station with the correct IP and MAC address. However, we know that sniffers do receive data not intended for them. In addition to understanding network addresses, it is also important to understand the format of the TCP header. The TCP header is comprised of the following fields: source port 16 bits, the source port number; destination port 16 bits, the destination port number; sequence number 32 bits, the sequence number of the first data octet in this segment. If SYN is present, the sequence number is the initial sequence number, and the first data octet is ISN plus 1. Acknowledgement number 32 bits. If the acknowledgement control bit is set, this field contains the value of the next sequence number the sender of the segment is expecting to receive. Data offset 4 bits, the number of 32-bit words in the TCP header. This indicates where the data begins. Reserved 6 bits, reserved for future use, must be 0. Control bit 6 bits. URG, urgent pointer field significant. ACK, acknowledgement field significant. PSH, push function. RST, reset the connection. SYN, synchronize sequence numbers. FIN, no more data from sender. Thank you. Hello everyone, welcome to my lecture. During a denial of service DOS attack, a hacker renders a system unusable or significantly slows the system by overloading resources or preventing legitimate users from accessing the system. These attacks can be perpetrated against an individual system or an entire network and are usually successful in their attempts. The hacking attack is one of the availability, meaning legitimate users no longer have access to the network. Session hijacking is a hacking method that creates a temporary DOS for an end user when an attacker takes over the session. Session hijacking is used by hackers to take over a current session after the user has established an authenticated session. Session hijacking can also be used to perpetrate a man-in-the-middle attack when the hacker steps between the server and legitimate client and intercepts all traffic. This lecture explains DOS attacks, distributed denial of service attacks, and the elements of session hijacking, such as spoofing methods, the TCP three-way handshake, sequence number prediction, and how hackers use tools for session hijacking. In addition, the countermeasures for DOS and session hijacking are discussed. Denial of service. A DOS attack is an attempt by a hacker to flood a user's or an organization's system. As a CEH, you need to be familiar with the types of DOS attacks and should understand how DOS and DDoS attack works. You should also be familiar with robots and robot networks as well as smurf attacks and SYN flooding. Finally, as a CEH, you need to be familiar with various DOS and DDoS countermeasures. There are two main categories of DOS attacks. 1. Attacks sent by a single system to a single target. 2. Attacks sent by many systems to a single target. The goal of DOS isn't to gain unauthorized access to machines or data, but to prevent legitimate users of a service from using it. A DOS attack may do the following: 1. Flood a network with traffic, thereby preventing legitimate network traffic. 2. Disrupt connections between two machines, thereby preventing access to a service. 3. Prevent a particular individual from accessing a service. 4. Disrupt service to a specific system or option. Different tools use different types of traffic to flood a victim, but the result is the same. A service on the system or the entire system is unavailable to a user because it's kept busy trying to respond to an exorbitant number of requests. How DDoS attack work? DDoS is an advanced version of the DDoS attack. Like DDoS tries to deny access to service running on a system by sending packets to the destination system in a way that the destination system can handle. The key of a DDoS attack is that it relies attacks from many different hosts. Hacking tools. Trino is a tool that sends user datagram protocol traffic to create a DDoS attack. The Trino master is a system used to launch a DDoS attack against one or more target system. The master instructs agent processes on previously compromised systems to attack one or more IP addresses. This attack occurs for a specified period of time. The Trino agent or daemon is installed on a system that suffers from a buffer overflow vulnerability. WinTrino is a Windows version of Trino and has the same functional as Trino. Seft is a derivative of the Trino tool that uses UDP communication between masters and agents. Seft provides statistics on the flood attack that attackers can use to know when the victim system is shut down. Seft provides UDP, ICMP and TCP flooding attack options. Tribal flood network allows an attacker to use both bandwidth depletion and resource depletion attacks. TFN does UDP and ICMP flooding as well as TCP, SYN and Smurf attacks. TFN2K is based on TFN with features designed specifically to make TFN2K traffic difficult to recognize and filter. It remotely executes commands, hides the sources of the attack using IP address spoofing, and uses multiple transport protocols. Stretchel Strat is similar to TFN and includes ICMF flood, UDP flood and TCP SYN attack options. It also provides a secure telnet connection using symmetric key encryption between the attacker and the agent system. This prevents system administrators from intercepting and identifying this traffic. MStream uses smoothed TCP packets with the ACK flag set to attack a target. It consists of a handler and an agent portion, but access to handler is password protected. The services under attack are those of the primary victim. The compromised systems used to launch the attack are secondary victims. These compromised systems which send the DDoS to the primary victim are sometimes called zombies or bots. They are usually compromised through another attack and then used to launch an attack on the primary victim at a certain time or under certain condition. It can be difficult to track the source of the attacks because they are originated from several IP addresses. Master and slaves in a DDoS attack are shown below. How bots/botnets work. A bot is short for web robot and is an automated software program that behaves intelligently. Spammers often use bots to automate the posting of spam messages on news groups or the sending of emails. Bots can also be used as remote attack tools. Most often, bots are web software agents that interface with web pages. For example, web crawlers, spiders are web robots that gather web page information. The most dangerous bots are those that covertly install themselves on users' computer for malicious purposes. Some bots communicate with other users of internet-based services via instant messaging, internet relay chat, or another web interface. These bots allow IRQ users to ask questions in plain English and then formulate a proper response. Such bots can often handle many tasks, including reporting weather, providing zip code information, listing sport scores, converting units of measures such as currency, and so on. A botnet is a group of bot systems. Botnets serve various purposes including DDoS attacks, creation or misuse of simple mail transfer protocol, mail relays for spam, internet marketing fraud, and the theft of application serial numbers, login IDs, and financial information such as credit card numbers. Generally, a botnet refers to a group of compromised systems running a bot for the purpose of launching a coordinated DDoS attack. Anatomy of a distributed DOS attack are shown below. Hello everyone, welcome to my lecture. Introduction. What is Kali? Kali is the latest and greatest version of the ever popular Backtrack Linux penetration testing distribution. The creators of the Backtrack series kept Kali in a format very similar to Backtrack, so anyone familiar with the older Backtrack platform will feel right at home. Kali has been revamped from the ground up to be the best and most feature-rich ethical hacking/pin testing distribution available. Kali also runs on more hardware devices, greatly increasing your options for computer security penetration testing or pin testing systems. If you are coming to Kali from a Backtrack background, after a short familiarization period, you should find that everything is very similar and your comfort level should grow very quickly. If you are new to Kali, once you get used to it, you will find an easy to use security testing platform that includes hundreds of useful and powerful tools to test and help secure your network systems. Why use Kali? Kali includes over 300 security testing tools. A lot of the redundant tools from Backtrack have been removed and the tool interface is streamlined. You can now get to the most used tools quickly as they appear in a top 10 security tool menu. You can also find these same tools and a plethora of others all neatly categorized in the menu system. Kali allows you to use similar tools and techniques that a hacker would use to test the security of your network, so you can find and correct these issues before a real hacking finds them. I would think the biggest drive to use Kali over commercial security solution is the price. Security testing tools can be extremely costly. Kali is free. Secondly, Kali includes open source versions of numerous commercial security products, so you could conceivably replace costly programs by simply using Kali. Although Kali does include several free versions of popular software programs that can be upgraded to the full features paid versions and used directly through Kali, there really are no major tool uses differences between Backtrack and Kali. Kali is basically Backtrack version 6 or the latest version of Backtrack, but it has been completely retooled from the ground up, making software updates and additions much easier. In Backtrack updating, some programs seemed to break others. In Kali, you update everything using the Kali update command, which keeps system integrity much better. Simply update Kali and it will pull down the latest versions of the included tools for you. Just a note of caution, updating tools individually could break Kali. So running the Kali update is always the best way to get the latest package for the OS. I must admit though, some tools that I like in the original Backtrack are missing in Kali. It is not too big of a deal as another tool in Kali most likely does the same or similar thing. And then again, you can install other programs you like if needed. In addition to standalone and virtual machine instances of Kali, I also use Kali on a Raspberry Pi, a mini credit card sized ARM based computer. With Kali, you can do almost everything on a Pi that you could do on a full sized systems. In my lecture, I will cover using the Pi as a security testing platform, including testing wireless networks. Testing networks with a computer you could fit in your pocket. How cool is that? Though Kali can't possibly contain all the possible security tools that every individual would prefer, it contains enough that Kali could be used from beginning to end. Don't forget that Kali is not just a security tool, but a full-fledged Linux operating system. So if your favorite tool runs under Linux, but is not included, most likely you can install and run it in Kali. Thank you. Hello everyone, welcome to my lecture, Password Attacks. Microsoft's support for Windows XP, SP3 and Office 2003 will officially end in April 8, 2014. With only 1 year of support left for Microsoft Windows XP, almost 40% of computer users still use it according to some reports. That is a huge number of Windows XP systems that are still being used in business critical positions. Computers do not just store passwords in plain text, but store them in an encrypted form. There are several different ways that computers encrypt their passwords. One of the most secure ways includes salting the password. Basically, this means to use a number and incorporate that into hashing process to ensure that no two passwords are ever the same. Cracking LM passwords online. There are several websites that will allow you to input a Windows LM hashes and it will return the password used. A Swiss security company called Objective Security has developed a cracking technology that uses rainbow tables on SSD drives. They offer an online demo of their technology that cracks many LM passwords in mere seconds. Not sure what kind of hash you have? There are several different types of hashes. Sometimes you might be able to retrieve a password hash, but might not be able to determine what type it is. Hash ID will identify the type of hash that you provide it. Simply run hash ID and input the hash. The program will check it and return the most likely type of hash that you have along with least likely types. From the Kali menu, Kali Linux /password attacks /offline attacks /hash identifier. Just paste in the hash and hash ID will try to determine what type it is. Looking up hashes in Kali. Looking up hashes manually online is interesting, but it would be better just to do it from within Kali. Well, you can with find my hash. Just a note, I really didn't have any luck recovering LM or NT-LM passwords using Find My Hash, which I thought was very odd, as one place it seemed to check is the object if security website. Not sure what is going on there, but it had no problem with MD5 hashes. Find My Hash encryption H hash. Conclusion. In this section, we learned that computers do not store passwords in plain text in the system's security database. The password is encrypted in some way and the resulting encrypted hash is recorded. We also learned that the Windows LM hash is not very secure and can be cracked very easily by using a simple looking up table or rainbow table as it is sometimes called. If the LM hash cannot be found in one of the online databases, then a cracking program is needed. You can turn off LM hashes, but security researchers have found that many network systems and programs still use them for backward capabilities. Pass the hash. In the previous section, we looked at how insecure Windows LM hash based passwords can be, but what about NT-LM based passwords? Windows systems usually store the NT-LM hash right along with LM hash, the NT-LM hash being more secure, and as I mentioned, the LM hash can be turned off. But what a lot of people have asked me is how much longer would it take to access the user account if only the NT-LM hash was available. This is a great question, and the answer is if certain circumstances are met and a certain technique is used, it could take same amount of time. Let me explain. If you can retrieve the LM or NT hashes from a computer, you do not need to crack them. There is really no need. Sometimes you can simply take the hash as is and use it as a token to access the system. This technique is called pass the hash. The pass the hash attack is not new. At the ever popular Black Hat USA conference last year, there was a presentation called Still Passing the Hash 15 years later. That should give you some idea how long this attack has been used. Thank you. Hello everyone, welcome to my lecture, Windows AV Bypass with Veil. Introduction. We took a quick look at attacking a Linux host. Now let's look at one of the attacking a Windows host. Many people think that if you are running an antivirus and a firewall, that they are generally safe from hacker attacks, but the truth is far from that. Meet Veil, a remote shell payload generator that can bypass many current antivirus programs. One part of penetration testing is getting past that pesky antivirus. Veil is one way that we can accomplish this. Many antivirus programs work by pattern or signature matching. If a program looks like malware that it has been programmed to look for, it catches it. If the malicious file has a signature that AV has not seen before, many will dutifully say that the file is clean and not a threat. If you can change or mask the signature of malware or a remote shell in this case, then most likely AV will allow it to run and the attacker gets a remote connection to the system. Veil, a new payload generator created by security expert and Black Hat USA class instructor Chris Transer, does just that. It takes a standard Metasploit payload and through a Metasploit-like program allows you to create multiple payloads that most likely will bypass antivirus. Installing Veil. Veil was recently added to Kali. If typing Veil at a terminal prompt does not start it, it may not be installed yet. To install, just type apt-get update and apt-get install Veil. Using Veil, the first thing to do is to list the available payload using the list command. The payloads are rated, and since we will be talking a little bit about PowerShell attacks, let's use a PowerShell payload. Just use the use command and the number of the payload. In this tutorial, we will use the PowerShell/virtual alloc payload. Type #use9. This will select the payload and present us with the following. At number 2, we will just use the default values, so just type generate. Then you can choose to use Metasploit standard MS Venom shellcode or choose your own. We will just choose the default ASM Venom. At 3, type 1 and enter. Next, choose the type of shell. We will just use the default, which is reverse TCP. This means that their computer will connect back to us. At number 4, just press enter to accept default shell payload. At number 5, next Veil will ask for the IP address of the host machine that you are using. Enter the IP address of your Kali machine and press enter. At 6, then enter the local port that you will be using. I used to choose 4000. At 7, you will then be asked to enter any MS Venom options that you want to use. We won't be using any, so just press enter to bypass them. And that is it. Veil will then generate our shell code with the options that we choose. At number 8, now we need to give our created file a name. I choose cute puppy. Okay, cute puppy sounds a little odd, but remember, you want the target to open the file that you are sending them, so a bit of social engineering is required. Getting a remote shell. To create the remote handler, we will be using Metasploit. Number 1, start the Metasploit framework from the menu or terminal. 2, now set up the multi-handler using the following screen. Be sure to put in the IP address for your machine and the port that you entered into Veil. They must match exactly. Metasploit will then start the handler and wait for a connection. Now we just need the victim to run the file that we sent them. On the Windows 7 machine, if the file is executed, we will see this on our Kali system, a reverse shell session. Then if we type shell, we see that we do in fact have a complete remote shell. Conclusion: this should help prove that you cannot trust in your firewall and antivirus alone to protect you from online threats. Unfortunately, many times your network security depends on your users and what they allow to run. Instruct your users to never run any programs or open any files that they get in an unsolicited email. Blocking certain file types from entering or leaving your network is also a good idea. And finally, using a network security monitoring system will help track down what happened and what was compromised if the worst does happen. Thank you. Hello everyone, welcome to my lecture, Windows Privilege Escalation by Bypassing USC. Introduction. The user administrator in Windows has a lot of authority, but there are some things that even an administrator cannot do. The user root in Linux is the super god level user, and in Windows the user system is the super user account. User access control seemed to be a nuisance in the previous Windows versions, and many companies just turned it off. Well, UAC works very well in Windows 7, and using it on even the lowest security setting prevents many attacks that work in Windows XP. Even if we get a remote administrator level session in Metasploit, UAC will prevent us from doing some things like obtaining password hashes, but there is a UAC bypass module in Meterpreter that will allow us to bypass this restriction and get system level if the user account we compromise is an administrator. In this section, we will learn how to escalate our privilege from an administrator level user to system level by bypassing UAC and creating a new session. UAC bypass. In this tutorial, we will start with an active Metasploit session with a Windows 7 system and a user that has administrator level rights. At first, number 1, we want to background the session. Then if we run the sessions command, we see that the only open Metasploit session is session 1. At number 2, now we need to use the bypassing exploit. At number 3, type show options to see what options we need to provide. At number 4, the only option we need to set is the set section option. Go ahead and set it to our active session, session 1 in this case, by using set command. At 5, and finally type exploit to run the bypass UAC module. Excellent, you can see that the user was in fact a member of the administrators group. The UAC bypass worked and a new session is created. Now if we try get to it again, we see it still says it is user friend, but if we run get system, it works. Now if we type get to it verifies that we need have systems level, or as far as Windows is concerned, good level rights. Now if we want, we can dump the system password hashes with the run post/windows/gather/hash dump command. The first part of the hash dump display above shows the 3 regular system users, Alice, Bob and George, and displays their logon password hint that they set when they created their password. And the final part shows the actual hashes from the system. Using the hashes to access a system or other systems on the network is covered in the password attack lecture. Conclusion. In this short section, we saw how to escalate a user that has administrator privileges to the super user system level account. We were able to do this by running a Metasploit module that allowed us to bypass the Windows user access control security feature. Once we have system level access, we can do anything that we want to do. We demonstrated this by dumping the password hashes from the security database. The UAC bypass was possible because the user account we had access to was an administrator level account. It is imperative that users always be given a non-administrator level account. The security repercussions to exceptions to this rule should be seriously considered. Thank you. Hello everyone, welcome to my lecture, DOS/DDoS countermeasures. There are several ways to detect, halt or prevent DOS attacks. The following are common security features. Network ingress filtering. All network access providers should implement network ingress filtering to stop any downstream network from injecting packets with faked or spoofed addresses into the internet. Although this doesn't stop an attack from occurring, it does make it much easier to track down the source of the attack and terminate the attack quickly. Most IDS, firewalls and routers provide network ingress filtering capabilities. Rate limiting network traffic. A number of routers on the market today have features that let you limit the amount of bandwidth some types of traffic can consume. This is sometimes referred to as traffic saving. Intrusion detection system. Use an intrusion detection system to detect attackers who are communicating with slave, master or agent machines. Doing so lets you know whether a machine in your network is being used to launch a known attack, but probably won't detect new variation of these attacks or the tools that implement them. Most IDS vendors have signatures to detect Trino, TFN or Staged network traffic. Automated network tracing tools. Tracing streams of packets with spoofed addresses through the network is a time-consuming task that requires the cooperation of all networks carrying the traffic, and that must be completed while the attack is in progress. Host auditing and network auditing tools. File scanning tools are available that attempt to detect the existence of known DDoS tool client and server binaries in a system. Network scanning tools attempt to detect the presence of DDoS agents running on hosts on your network. DDoS scanning tools. Find DDoS is a tool that scans a local system that likely contains a DDoS program. It can detect several known DOS attack tools. SARA gathers information about remote hosts and networks by examining network services. This includes information about the network information services as well as potential security flaws, such as incorrectly set up or configured network services, well-known bugs in the system or network utilities, system software vulnerabilities listed in the Common Vulnerabilities and Exposures database, and weak policy decision. RID is a free scanning tool that detects the presence of Trino, TFN or staged clients. Zombie Zapper instructs zombie routines to go to sleep, thus stopping their attack. You can use the same commands an attacker would use to stop the attack. Session hijacking. Session hijacking is when a hacker takes control of a user session after the user has successfully authenticated with a server. Session hijacking involves an attack identifying the correct session IDs of a client/server communication and taking over the client session. Session hijacking is made possible by tools that perform sequence number prediction. The details of sequence number prediction will be discussed later in this lecture in the sequence prediction section. Spoofing attacks are different from hijacking attacks. In a spoofing attack, the hacker performs sniffing and listens to traffic as it's passed along the network from sender to receiver. The hacker then uses the information gathered to spoof or uses an address of a legitimate system. Hijacking involves actively taking another user offline to perform the attack. The attacker relies on the legitimate user to make a connection and authenticate. After that, the attacker takes over the session and the valid user session is disconnected. Thank you. Hello everyone, welcome to my lecture. Sequence prediction. TCP is a connection-oriented protocol responsible for resembling streams of packet into their original intended order. Every packet has to be assigned a unique session number that enables that receiving machine to resemble the stream of packets into their original and intended order. This unique number is known as a sequence number. If the packets arrive out of order, as happens regularly over the internet, then the SN is used to stream the packets correctly. As just illustrated, the system initiating a TCP session transmits a packet with the sync bit set. This is called a synchronized package and include the client's ISN. The ISN is shadowed randomly generated number with over 4 billion possible combinations, yet it is statistically possible for it to repeat. When the ACK packet is sent, each machine uses the SN from the packet being acknowledged plus an increment. This not only properly confirms receipt of a specific packet, but also tells the sender the next expected TCP packet SN. Within the three-way handshake, the increment value is 1. In normal data communications, the increment value equals the size of the data in bytes. Hacking tools used to perform session hijacking do sequence number prediction. To successfully perform a TCP sequence prediction attack, the hacker must sniff the traffic between two systems. Next, the hacker or the hacking tool must successfully gauge the SN or locate an ISN to calculate the next sequence number. This process can be more difficult than it sounds because packets travel very fast. When a hacker is unable to sniff the connection, it becomes much more difficult to guess the next SN. For this reason, most session hijacking tools include features to permit sniffing to packets to determine the SNs. Hackers generate packets using a spoofed IP address of the system that had a session with the target system. The hacking tool issue packets with the SNs that the target system is expecting, but the hacker packets must arrive before the packets from the trusted system whose connection is being hijacked. This is accomplished by flooding the trusted system with packets or sending an RST packets to the trusted system so that it is unavailable to send packets to the target system. Dangers posed by session hijacking. TCP session hijacking is a dangerous attack. Most systems are vulnerable to it because they use TCP/IP as their primary communication protocol. Newer operating systems have attempted to secure themselves from session hijacking by using shadow random number generators to calculate the ISN, making the sequence number harder to guess. However, this security measure is ineffective if the attacker is able to sniff packets, which gives all the information required to perform this attack. Preventing session hijacking. To defend against session hijack attacks, a network should employ several defenses. The most effective protection is encryption, such as Internet Protocol security. This also defends against any other attack vectors that depend on sniffing. Attackers may be able to passively monitor your connection, but they won't be able to interpret the encrypted data. Other countermeasures include using encrypted applications such as Secure Shell and Secure Sockets layer. You can help prevent session hijacking by reducing the potential methods of gaining access to your network. For example, by eliminating remote access to internal systems. If the network has remote users who need to connect to carry out their duties, then use virtual private networks that have been secured with tunneling protocols and encryption. The use of multiple safety nets is always the best countermeasures to any potential threat. Employing any one countermeasures may not be enough, but using them together to secure your enterprise will make their attacks success rate minimal for anyone but the most professional and dedicated attacker. Thank you. Hello everyone, welcome to my lecture. Buffer overflows. As a CEH, you must be able to identify different types of buffer overflows. You should also know how to detect a buffer overflow vulnerability and understand the steps a hacker may use to perform a stack-based overflow attack. We will look at this topic as well as provide an overview of buffer overflow mutation techniques below. Types of buffer overflows and methods of detection. Buffer overflows are exploits that hackers use against an operating system or application, like SQL injection attacks. They are usually targeted at user input fields. A buffer overflow exploit causes a system to fail by overloading memory or executing a command shell or arbitrary code on the target system. A buffer overflow vulnerability is caused by a lack of bounds checking or a lack of input validation sanitization in a variable field, such as on the web form. If the application doesn't check or validate the size or format of a variable before sending it to be stored in memory, an overflow vulnerability exists. The two types of buffer overflow are stack-based and heap-based. The stack and the heap are storage location for user supplied variables within a running program. Variables are stored in the stack or heap until the program needs them. Stacks are static locations of memory address space, whereas heaps are dynamic memory address space that occur while a program is running. A heap-based buffer overflow occurs in the lower part of the memory and overrides other dynamic variables. A call stack or stack is used to keep track of where in the programming code the execution pointer should return after each portion of the code is executed. A stack-based buffer overflow attack occurs when the memory assigned to each execution routine is overflowed. As a consequence of both types of buffer overflows, a program can open a shell or command prompt or stop the execution of a program. A stack-based buffer overflow attack are shown below. To detect program buffer overflow vulnerabilities that results from poorly written source code, a hacker sends large amounts of data to the application via a form field and sees what the program does as a result. The following are the steps a hacker uses to execute a stack-based buffer overflow. Number 1. Enter a variable into the buffer to exhaust the amount of memory in the stack. 2. Enter more data than the buffer has allocated in memory for that variable, which causes the memory to overflow or run into the memory space for the next process. Then add another variable and override the return pointer that tells the program where to return to after executing the variable. A program executes this malicious code variable and then uses the return pointer to get back to the next line of executable code. If the hacker successfully overwrites the pointer, the program executes the hacker's code instead of the program code. Most hackers don't need to be this familiar with the details of buffer overflows. Pre-written exploits can be found on the internet or exchanged between hacker groups. Remember, the memory register that gets overwritten with the return address of the exploit code is known as the EIP. Buffer overflow countermeasures. As you can see, hackers can graduate from standard buffer overflows to redirecting the return pointer to the code of their choosing. A hacker must know the exact memory address and the size of the attack in order to make the return pointer execute their code. A hacker can use a no operation instruction, which is just padding to move the instruction pointer and does not execute any code. The NOP instruction is added to a string before the malicious code to be executed. If an intrusion detection system is present on the network, it can threat a hacker who sends a series of NOP instructions to forward to the instruction pointer. To bypass IDS, the hacker can randomly replace some of the NOP instruction with equivalent pieces of code. Programs should not use the built-in strcpy, strcat and c/c++ function because they are susceptible to buffer overflows. Alternatively, Java can be used as the programming language since Java is not susceptible to buffer overflows. Thank you. Hello everyone, welcome to my lecture, Cryptography. Cryptography is the study of encryption and encryption algorithms. In a practical sense, encryption is the conversion of message from a comprehensible form into an incomprehensible one and back again. The purpose of encryption is to render data unreadable by interceptors or eavesdroppers who do not know the secret of how to decrypt the message. Encryption attempts to ensure secrecy in communications. Cryptography defines the techniques used in encryption. This lecture will discuss its encryption algorithms and cryptography. Cryptography and encryption techniques. Encryption can be used to encrypt data while it is in transit or while it's stored on a hard drive. Cryptography is the study of protecting information by mathematically scrambling the data so it cannot be deciphered without knowledge of the mathematical formula used to encrypt it. This mathematical formula is known as the encryption algorithm. Cryptography is composed of two words, crypt meaning secret or hidden and graphy meaning writing. Cryptography literally means secret or hidden writing. Clear text is the readable and understandable data, and cipher text is the scrambled text as a result of the encryption process. ciphertext should be unreadable and show no repeatable pattern to ensure the confidentiality of the data. Clear text versus ciphertext picture are shown below. There are three critical elements to data security. Confidentiality, integrity, and authentication are known as the CIA triad. Data encryption provides confidentiality, meaning the data can only be read by authorized users. Message hashing provides integrity, which ensures the data sent is the same data received and the information was not modified in transit. Message digital signatures provide authentication, ensuring users are who they say they are, as well as integrity. Message encryption and digital signatures together provide confidentiality, authentication, and integrity. The CIA triad picture are shown below. Encryption algorithms can use simple methods of scrambling characters, such as substitution, replacing characters with other characters, and transposition, changing the order of characters. Encryption algorithms are mathematical calculation based on substitution and transposition. Here are some early cryptographic systems. Caesar cipher, a simple substitution cipher. Adbase cipher, used by the ancient Hebrews. Adbase is a substitution cipher and works by replacing each letter used with another letter the same distance away from the end of the alphabet. For example, A would be sent as a Z and B would be sent as a Y. Vigenère cipher. 16th century French cryptographer Blaise de Vigenère created a polyalphabetic cipher to overcome the shortcomings of simple substitution ciphers. The Vigenère cipher uses a table to increase the available substitution values and make the substitution more complex. The substitution table consists of columns and row labeled A to Z. To get ciphertext, first you select the column of plain text and then you select the row of the key. The intersection of row and column is called ciphertext. To decode ciphertext, you select the row of the key and find the intersection that is equal to ciphertext. The label of the column is called plain text. Varnum cipher. In 1917, AT&T Bell Labs engineer Gilbert Varnum sought to improve the Vigenère cipher and ended up creating the Varnum cipher, or one-time pad. The Varnum cipher is an encryption algorithm where the plain text is combined with a random key or pad that is the same length as the message. One-time pads are the only algorithm that is probably unbreakable by the brute force. Concealment cipher. A concealment cipher creates a message that is concealed in some ways. For example, the following paragraph includes a secret message. I have been trying to buy Sally some nice jewelry like gold or silver earrings, but price now have increased. The key is to look at every 6 word in a sentence. So the secret message is buy gold now. Thank you. Hello everyone, welcome to my lecture. Stream cipher versus block ciphers. Block ciphers and stream ciphers are the two types of encryption ciphers. Block ciphers are encryption ciphers that operate by encrypting a fixed amount or block of data. The most common block size is 64 bits of data. This chunk or block of data is encrypted as 1 unit of clear text. When a block cipher is used for encryption and decryption, the message is divided into blocks of bits. Blocks are then put through one or more of the following scrambling methods. 1. Substitution. 2. Transposition. 3. Confusion. 4. Diffusion. 5. S-boxes. A stream cipher encrypts single bits of data as a continuous stream of data bits. Stream cipher typically execute at a higher speed than block cipher and are suited for hardware uses. The stream cipher then combines a plain text bit with a pseudo-random cipher bit stream by means of an XOR operation. The XOR process is to compare the plain text and key one bit at a time, and based on the XOR logic create cipher text. If the plain text and secret key are the same bit, the result is a 0. If they are different, such as 1 and 0, then the resulting encrypted bit is a 1. Generating public and private keys. When a client and a server use asymmetric cryptography, both create their own pairs of keys for a total of 4 keys. The server's public key, the server's private key, the client's public key, and the client's private key. A system's key pair has a mathematical relationship that allows data encrypted with one of the keys to be decrypted with the other key. These keys have a mathematical relationship based on factoring prime numbers such that each key can be used to decrypt data encrypted with the other key. When a client and a server want to mutually authenticate and share information, they each send their own public key to the remote system, but they never share their private keys. Each message is encrypted with the receiver's public key. Only the receiver's private key can decrypt the message. The server would encrypt a message to the client using the client's public key. The only key that can decrypt the message is held by the client, which ensures confidentiality. A public key infrastructure is necessary in order to create digital certificates. PKI is a framework that consists of hardware, software, policies that exist to manage, create, store, and distribute keys and digital certificates. Additionally, a complete PKI solution involves symmetric algorithms, asymmetric algorithms, hashing, and digital authentication. One of the major strengths of public key encryption is its ability to facilitate communication between parties previously unknown to each other, a process that is made possible by the PKI hierarchy of trust relationships. The important parts of the PKI infrastructure are as follows: digital certificates, certificates authorities, certificate generation and destruction, key management. CAs are the glue that binds the public key infrastructure together. They are essentially neutral third-party organizations that provide notarization services for digital certificates. To obtain a digital certificate from a reputable CA, you must identify and prove identity. Digital certificates are formatted to the X.509 standard and contain set fields. These fields include version, serial number, algorithm ID, issuer, validity, not before a specific date, not after a specific date, subject, subject public key information, public key algorithms, subject public key, issuer unique identifier, subject unique identifier, extensions. Thank you. Hello everyone, welcome to my lecture. Password management. Passwords are often the path of least resistance on pen testing engagements. A client with a strong security program can fix missing Windows patches and out-of-date software, but the users themselves can't be patched. We will look at attacking users when we discuss social engineering later, but if we can correctly guess or calculate a user's password, we may be able to avoid involving the user in the attack at all. In this lecture, we will look at how to use tools to automate running services on our targets and sending usernames and password. Password management. Companies are waking up to the inherent risk of password-based authentication. Brute force attacks and educated guesses are both serious risks to weak passwords. Many organizations use biometric or two-factor authentication to mitigate this risk. Even web services such as Gmail and Dropbox offer two-factor authentication in which the user provides a password as well as a second value, such as the digits on an electronic token. If two-factor authentication is not available, using a strong password is imperative for account security, because all that stands between the attackers and sensitive data may come down to a simple string. Strong passwords are long, use characters from multiple complexity classes, and are not based on a dictionary word. The passwords we use in this lecture are deliberately terrible, but unfortunately many users don't behave much better when it comes to passwords. Organization can force users to create strong passwords, but as passwords become more complex, they become harder to remember. Users are likely to leave a password that they can't remember in a file on their computer, in their smartphone, or even on a post-it note, because it's just easier to keep up track them that way. Of course, passwords that can be discovered lying around in plain text undermine the security of using a strong password. Another cardinal sin of good password management is using the same password on many sites. In a worst case scenario, the CEO's weak password for a compromised web forum might just be the very same one for his or her corporate access to financial documents. Password reuse in something to bear in mind while performing password attacks. You may find the same password work on multiple systems and sites. Password management presents a difficult problem for IT staff and will likely continue to be a fruitful avenue for attacks unless or until password-based authentication is phased out entirely in favor of another model. One-line password attacks. Just as we used automated scans to find vulnerabilities, we can use scripts to automatically attempt to log into services and find valid credentials. We will use tools designed for automating online password attacks or guessing password until the server responds with a successful login. These tools use a technique called brute forcing. Tools that use brute forcing try every possible username and password combination, and given enough time, they will find valid credentials. The trouble with brute forcing is that as stronger passwords are used, the time it takes to brute force them moves from hours to years and even beyond your natural lifetime. We can probably find working credentials more easily by feeding educated guesses about the correct passwords into an automated login tool. Dictionary words are easy to remember, so despite the security warnings, many users incorporate them into passwords. Slightly more security conscious users might put some numbers at the end of their password or maybe even an exclamation point. Word list. Before you can use a tool to guess passwords, you need a list of credentials to try. If you don't know the name of the user account you want to crack, or you just want to crack as many accounts as possible, you can provide a username list for the password guessing tool to iterate through. User list. When creating a user list, first try to determine the client's username scheme. For instance, if we are trying to break into employee email accounts, figure out the pattern the email addresses follow. Are they first name dot last name, just a first name or last name? Else, you can look for good username candidates on list of common first or last names. Of course, the guesses will be even more likely to succeed if you can find the names of your target actual employees. If a company uses a first initial followed by a last name for the username scheme and they have an employee named John Smith, J. Smith is likely a valid username. Once you have created your list, save the sample usernames in a text file in Kali Linux. Like our username list, this password list is just a very short example and one that hopefully wouldn't find the correct passwords for too many accounts in the real world. On a real engagement, you should use a much longer word list. There are many good password lists available on the internet. Good places to look for word lists include http://packetstormsecurity.com/cracker/wordlist. A few password lists are also built into Kali Linux. This is a compressed word list. If you unzip the file with the gunzip Linux utility, you will have about 140 MB of possible passwords, which should give you a pretty good start. Also, some of the password cracking tools in Kali come with sample word list. For example, the John the Ripper tool. For better results, customize your word list for a particular target by including additional word. You can make educated guesses based on information you gather about employees online. Information about spouses, children, pets, and hobbies may put you on the right track. Guessing usernames and passwords with Hydra. If you have a set of credentials that you would like to try against a running service that requires a login, you can input them manually one by one or use a tool to automate the process. Hydra is an online password guessing tool that can be used to test usernames and passwords for running services. Following the traditional of naming security tools after the victims or Hercules levers, Hydra is named for the mythical Greek serpent with many heads. Use Hydra to guess usernames and passwords by running through our username and password files to search for valid POP3 credentials on our Windows XP target. This command uses the L flag to specify the username file, the P for the password list file, and specifies the protocol POP3. Hydra finds that user Georgia's password is password at shame on Georgia for using such an insecure password. Sometimes you will know that a specific username exists on a server and you just need a valid password to go with it. For example, we use the SMTP VRFY verb to find valid usernames on the SL mail server on the Windows XP target. As you can see in listing 926, we can use the I flag instead of L to specify one particular username. Specify the POP3 protocol and provide the username and password when prompted. Hydra can perform online password guessing against a range of services. For example, here we use the credential we found with Hydra to log in with Netcat. One way to avoid having your login attempts noticed is to try to guess a password before trying to log in, as you will learn later. Hello everyone, welcome to my lecture, Password Attacks. Microsoft's support for Windows XP, SP3 and Office 2003 will officially end in April 8, 2014. With only 1 year of support left for Microsoft Windows XP, almost 40% of computer users still use it according to some reports. That is a huge number of Windows XP systems that are still being used in business critical positions. Computers do not just store passwords in plain text, but store them in an encrypted form. There are several different ways that computers encrypt their passwords. One of the most secure ways includes salting the password. Basically, this means to use a number and incorporate that into hashing process to ensure that no two passwords are ever the same. Cracking LM passwords online. There are several websites that will allow you to input a Windows LM hashes and it will return the password used. A Swiss security company called Objective Security has developed a cracking technology that uses rainbow tables on SSD drives. They offer an online demo of their technology that cracks many LM passwords in mere seconds. Not sure what kind of hash you have? There are several different types of hashes. Sometimes you might be able to retrieve a password hash, but might not be able to determine what type it is. Hash ID will identify the type of hash that you provide it. Simply run hash ID and input the hash. The program will check it and return the most likely type of hash that you have along with least likely types. From the Kali menu, Kali Linux /password attacks /offline attacks /hash identifier. Just paste in the hash and hash ID will try to determine what type it is. Looking up hashes in Kali. Looking up hashes manually online is interesting, but it would be better just to do it from within Kali. Well, you can with find my hash. Just a note, I really didn't have any luck recovering LM or NT-LM passwords using find my hash, which I thought was very odd, as one place it seemed to check is the object if security website. Not sure what is going on there, but it had no problem with MD5 hashes. Find my hash encryption H hash. Conclusion. In this section, we learned that computers do not store passwords in plain text in the system's security database. The password is encrypted in some way and the resulting encrypted hash is recorded. We also learned that the Windows LM hash is not very secure and can be cracked very easily by using a simple looking up table or rainbow table as it is sometimes called. If the LM hash cannot be found in one of the online databases, then a cracking program is needed. You can turn off LM hashes, but security researchers have found that many network systems and programs still use them for backward capabilities. Pass the hash. In the previous section, we looked at how insecure Windows LM hash based passwords can be, but what about NT-LM based passwords? Windows systems usually store the NT-LM hash right along with LM hash, the NT-LM hash being more secure, and as I mentioned, the LM hash can be turned off. But what a lot of people have asked me is how much longer would it take to access the user account if only the NT-LM hash was available. This is a great question, and the answer is if certain circumstances are met and a certain technique is used, it could take same amount of time. Let me explain. If you can retrieve the LM or NT hashes from a computer, you do not need to crack them. There is really no need. Sometimes you can simply take the hash as is and use it as a token to access the system. This technique is called pass the hash. The pass the hash attack is not new. At the ever popular Black Hat USA conference last year, there was a presentation called Still Passing the Hash 15 years later. That should give you some idea how long this attack has been used. Thank you. Hello everyone, welcome to my lecture MSF encode. The shell code generated by MSF payload is fully functional, but it contains several null characters that when interpreted by many programs signify the end of a string, and this will cause the code to terminate before completion. In other words, those X00S and XFFS can break your payload. In addition, shell code traversing a network in clear text is likely to be picked up by intrusion detection systems and antivirus software. To address this problem, Metasploit's developers offer MSF encode, which helps you to avoid bad characters and evade antivirus and IDSs by encoding the original payload in a way that does not include bad characters. Enter MSF encode Ace to see a list of MSF encode options. Metasploit contains a number of different encoders for specific situations. Some will be useful when you can use only alphanumeric characters as part of a payload, as is the case with many file format exploits or other applications that accept only printable characters as input, while others are great general purpose encoders that do well in every situation. When in doubt, though, you really can't go wrong with the x86/Sikata Go9 encoder, the only encoder with the rank of excellent, a measure of the reliability and stability of a module. In the context of an encoder, an excellent ranking implies that it is one of the most versatile encoders and can accommodate a great degree of fine-tuning than other encoders. To see the list of encoders available, append 1 to MSF encode as shown next. The payloads are ranked in order of reliability. NASM cell. The NASM cell.rv utility can be handy when you are trying to make sense of assembly code, especially if during exploit development you need to identify the opcodes for a given assembly command. For example, here we run the tool and request the opcodes for the JMP ESP command, which NASM cell tells us is FFE4. Metasploit Express and Metasploit Pro. Metasploit Express and Metasploit Pro are commercial web interfaces to the Metasploit framework. These utilities provide substantial automation and make things easier for new users, while still providing full access to the framework. Both products also provide tools that are unavailable in the community editions of the framework, such as automated password brute forcing and automated website attacks. In addition, a nice reporting backend to Metasploit Pro can speed up one of the least popular aspects of penetration testing, writing the report. Are these tools worth purchasing? Only you can make that choice. The commercial edition of Metasploit are intended for professional penetration testers and can ease many of the more routine aspects of the job. But if the time savings from the automations in these commercial products are useful for you, they might justify the purchase price. Remember, however, as you automate your work, that humans are better at identifying attack vectors than automated tools. Wrapping up, in this lecture, you learned a little bit of the basics of the Metasploit framework. As you progress through this lecture, you will begin using these tools in a much more advanced capacity. You will find a few different ways to accomplish the same task using different tools. It will ultimately be up to you to decide which tool best suits your needs. Now that you have the basics under control, let's move to the next phase of the pen testing process: discovery. Thank you. Hello everyone, welcome to my lecture, Metasploit Basics. When you encounter the Metasploit framework MSF for the first time, you might be overwhelmed by its many interfaces, options, utilities, variables and modules. In this lecture, we will focus on the basics that will help you make sense of the big picture. We will review some basic penetration testing terminology and then briefly cover the various user interfaces that Metasploit has to offer. Metasploit itself is free, open source software with many contributors in the security community, but two commercial Metasploit versions are also available. When first using Metasploit, it's important not to get hung up on that newest exploit. Instead, focus on how Metasploit functions and what commands you use to make the exploit possible. Terminology. Throughout this lecture, we will use various terms that first bear some explanation. The majority of the following basic terms are defined in the context of Metasploit, but they are generally the same throughout the security industry. Exploit. An exploit is the means by which an attacker, or open tester for that matter, takes advantages of a flaw within a system, an application or a service. An attacker uses an exploit to attack a system in a way that results in a particular desired outcome that the developer never intended. Common exploits include buffer overflows, web application vulnerabilities such as SQL injection, and configuration errors. Payload. A payload is code that we want the system to execute and that is to be selected and delivered by the framework. For example, a reverse shell is a payload that creates a connection from the target machine back to the attacker as a Windows command prompt, whereas a bind shell is a payload that binds a command prompt to a listening port on the target machine, which the attacker can then connect. A payload could also be something as simple as a few commands to be executed on the target operating system. Shellcode. Shellcode is a set of instructions used as a payload when exploitation occurs. Shellcode is typically written in assembly language. In most cases, a command shell or a meterpreter shell will be provided after the series of instructions have been performed by the target machine, hence the name. Module. A module in the context of this lecture is a piece of software that can be used by the Metasploit framework. At times, you may require the use of an exploit module, a software component that conducts the attack. Other times, an auxiliary module may be required to perform an action such as scanning or system enumeration. These interchangeable modules are the core of what makes the framework so powerful. Listener. A listener is a component within Metasploit that waits for an incoming connection of some sort. For example, after the target machine has been exploited, it may call the attacking machine over the internet. The listener handles that connection, waiting on the attacking machine to be contacted by the exploited system. Metasploit interfaces. Metasploit offers more than one interface to its underlying functionality, including console, command line, and graphical interfaces. In addition to these interfaces, utilities provide direct access to functions that are normally internal to the Metasploit framework. These utilities can be invaluable for exploit development and situations for which you do not need the flexibility of the entire framework. MSF console. MSF console is by far the most popular part of the Metasploit framework, and for good reason. It is one of the most flexible, feature-rich, and well-supported tools within the framework. MSF console provides a handy wall-in-wall interface to almost every option and setting available in the framework. It's like a one-stop shop for all of your exploitation dreams. You can use MSF console to do everything, including launching an exploit, loading auxiliary modules, performing enumeration, creating listeners, or running mass exploitation against an entire network. Although the Metasploit framework is constantly changing, a subset of commands remain relatively constant. By mastering the basics of MSF console, you will be able to keep up with any changes. To illustrate the importance of learning MSF console, it will be used in nearly every lecture. Starting MSF console. To launch MSF console, enter MSF console at the command line. Root at bt /cd/opt/framework3/msf3. Root at bt/opt/framework/msf3 #msf console. Metasploit. To access MSF console help files, enter help followed by the command which you are interested in. In the next example, we are looking for help for the command connect, which allows us to communicate with a host. The resulting documentation list uses a description of the tool and the various option flags. MSF CLI. MSF CLI and MSF console take very different approaches to providing access to the framework. Where MSF console provides an interactive way to access all features in a user-friendly manner, MSF CLI puts the priority on scripting and interpretability with other console-based tools. Instead of providing a unique interpreter to the framework, MSF CLI runs directly from the command line, which allows you to redirect output from other tools into MSF CLI and direct MSF CLI output to other command line tools. MSF CLI also supports the launching of exploits in auxiliary modules, and it can be convenient when testing modules or developing new exploits for the framework. It is a fantastic tool for Unix exploitation when you know exactly which exploit and option you need. It is less forgiving than MSF console, but it offers some basic help with the command MSF CLI H. Sample uses. Let's take a look at how you might use MSF CLI. Don't worry about the details. These examples are intended to give you a sense of how you might work with this interface when you are first learning Metasploit, or whenever you get stuck. You can see options available in the module by appending the letter 0 to the end of the string at whichever point you are stuck. For example, in the following listing, we use the 0 to see the option available for the MS08067 NetAPI module. Root at hashtag MSF CLI window /smb/ms08067 NetAPI 0. Please wait while we load the module tree. Our name our host, current setting 0.0.0.0, required yes, description the target addresses, name our port, current setting 445, required yes, description set the SMB service port, name SMB pipe, current setting browser, required yes, description the pipe name to use bracket browser.srv.svc bracket close. You can see that the module requires three options: rhost, rport and SM pipe. Thank you. Hello everyone, welcome to my lecture, Recon Tools. Introduction. There are several tools in Kali Linux to aid in information gathering and reconnaissance. When a hacker attacks a target, one of the normal stages they perform is information gathering. They want to learn as much about your network, their target as they can to make their lives easier. Meltego is a very popular tool, one that is covered quite a bit in security lecture and training seminars. As it already has a lot of coverage, I figured we would look at some of the other tools included in Kali. ReconNG. The ReconNG framework is a powerful tool that allows you to perform automated information gathering and network reconnaissance. Think of it as Metasploit for information collection. ReconNG automates a lot of the steps that are taken in the initial process of a penetration test. It has numerous features that allow you to collect user information for social engineering attacks and network information for network mapping and much more. You can automatically hit numerous websites to gather passive information on your target and even actively probe the target itself for data. Anyone who is familiar with Metasploit will feel right at home, as the interface was made to have the same look and feel. The command use and functions are very similar. Basically, you can use ReconNG to gather info on your target and then attack it with Metasploit. Using ReconNG. To start ReconNG, just open a terminal prompt and type ReconNG. Type help to bring up a list of commands. Now, like Metasploit, you can type show modules to display a list of available modules. Some of the modules are passive, they never touch the target network, while some directly probe and can even attack the system you are interested in. One tactic used to passively probe network structure is to use the Google search engine to enumerate site subdomains. You know that there will be a main domain like some targetname.com, but what other domains are out there? You can do a Google search for subdomains using the site and INURL switches, then remove subdomains that you find, so other subdomains will appear. This can take a while to do by hand and can require a lot of typing if the target has a large number of subdomains. ReconNG will do this for you automatically and record what it finds in a database. Just use the recon/host/gather/http/web/google site module, then show options to see what the module requires. This one only requires the target domain. As in Metasploit, just type set domain targetname.com, then just type run and the module will execute. ReconNG wrap up. Subdomain enumeration is only one module you can run. There are many others to choose from. There are also some that require a program API key like Twitter, Shodan, LinkedIn or Google. Using these, you can get specific information from the corresponding sites about your targets. For example, you can search Twitter for tweets from your target or even check Shodan for open systems. I have just briefly touched on some of the capabilities of ReconNG. It is really an impressive tool that is well worth checking into. Dimitri is a nice little tool for quickly finding out information about a site. Just run Dimitri from the menu or command line. Dimitri, some domainname.com, will perform a similar scan as demonstrated in the ReconNG section. NetDiscover is another neat tool included in Kali. It too can be run from the command prompt or from the menu system. NetDiscover scans a network looking for devices and then displays them. It can also run in stealth passive mode where it doesn't send any data, it only sniffs traffic. Zenmap is basically a graphical version of the ever popular Nmap command. If you are not familiar with Nmap, then Zenmap is a great place to start. Thank you. Hello everyone, welcome to my lecture, Vulnerability Scanning. A vulnerability scanner is an automated program designed to look for weaknesses in computers, computer systems, networks, and applications. The program probes a system by sending data to it over a network and analyzing the responses received in an effort to enumerate any vulnerabilities present on the target by using its vulnerability database as reference. Various operating systems tend to respond differently when sent particular network probes because of the different networking implementations in use. These unique responses serve as a fingerprint that the vulnerability scanner uses to determine the operating system version and even its patch level. A vulnerability scanner can also use a given set of user credentials to log into the remote system and enumerate the software and services to determine whether they are patched. With the results it obtains, the scanner presents a report outlining any vulnerabilities detected on the system. That report can be useful for both network administrators and penetration testers. Vulnerability scanners generally create a lot of traffic on a network and are therefore not typically used in a penetration test when one of the objectives is to remain undetected. If, however, you are running a penetration test and stealth is not an issue, a vulnerability scanner can save you from having to probe system manually to determine their patch levels and vulnerabilities. Whether you use an automated scanner or do it manually, scanning is one of the most important steps in the penetration testing process. If done thoroughly, it will provide the best value to your client. In this lecture, we will discuss a number of vulnerability scanners and how they can be integrated within Metasploit. We will highlight some auxiliary modules in the Metasploit framework that can locate specific vulnerabilities in remote systems. The basic vulnerability scan. Let's look at how a scan works at the most basic level. In the following listing, we will netcat to grab a banner from the target 192.168.1.203. Banner grabbing is the act of connecting to a remote network service and reading the service identification that is returned. Many network services such as web, file transfer, and mail servers return their banner either immediately upon connecting to them or in response to a specific command. Here we connect to a web server on TCP port 80 and issue a GET HTTP request that allows us to look at the header information that the remote server returns in response to our request. The information returned at number 1 tells us that the system running on port 80 is a Microsoft IIS 5.1 based web server. Armed with this information, we could use a vulnerability scanner to determine whether this version of IIS has any vulnerabilities associated with it and whether this particular server has been patched. Of course, in practice, it's not that simple. Vulnerability scans often contain many false positives and false negatives due to subtle difference in system and application configurations. In addition, the creators of vulnerability scanners have an incentive to report positives. The more hits a vulnerability scanner finds, the better it looks to a potential buyer. Vulnerability scanners are only as good as their vulnerabilities database, and they can easily be fooled by misleading banners or inconsistent configurations. Let's take a look at some of the more useful vulnerability scanners, including Nexpose, Nessus, and some specialized scanners. Scanning with Nexpose. Nexpose is Rapid 7's vulnerability scanner that scans network to identify the device running on them and performs check to identify security weaknesses in operating system and applications. It then analyzes the scan data and processes it for inclusion in various reports. Rapid 7 offers multiple versions of Nexpose, but we will use the community edition because it's free. If you plan to use Nexpose commercially, see the Rapid 7 site for information on the various versions and their capabilities and pricing. Our target for scanning will be a default installation of Windows XP SP2 as configured in Appendix A. We will first perform a basic overt scan of our target and import the vulnerability scan results into Metasploit. We will close out this section by showing you how to run an Nexpose vulnerability scan directly from MSF console rather than using the web-based GUI, eliminating the need to import a scan report. Thank you. Hello everyone, welcome to my lecture, Intelligence Gathering. Intelligence gathering follows the pre-engagement activities as the second step in a penetration test. Your goals during intelligence gathering should be to gain accurate information about your targets without revealing your presence or your intention, to learn how the organization operates and to determine the best route of entry. NS lookup. To get additional server information, we will use backtrack to leverage NS lookup, a tool built into most operating systems, to find information about Segmaniac.net. We see in this listing that the mail servers are pointing to mailstore1.secureserver.net and smtp.secureserver.net. Some quick research on these mail servers tell us that this website is hosted by a third party, which would not be within the scope of our penetration test. At this point, we have gathered some valuable information that we might be able to use against the target later on. Ultimately, however, we have to resort to active information gathering techniques to determine the actual target IP, which is 75.118.185.142. Remember, passive information gathering is an art that is not easily mastered in just a few pages of discussion. Active information gathering. In active information gathering, we interact directly with a system to learn more about it. We might, for example, conduct port scans for open ports on the target or conduct scans to determine what services are running. Each system or running service that we discover gives us another opportunity for exploitation. But beware, if you get careless while active information gathering, you might be nabbed by an IDS or intrusion prevention system. Not a good outcome for the covert penetration tester. Port scanning with Nmap. Having identified the target IP range with passive information gathering as well as the Checkmaniac.net target IP address, we can begin to scan for open ports on the target by port scanning, a process whereby we meticulously connect to ports on the remote host to identify those that are active. Nmap is by far the most popular port scanning tool. It integrates with Metasploit quite elegantly, storing scan output in a database backend for later use. Nmap lets you scan hosts to identify the service running on each, any of which might offer a way in. For this example, let's leave Checkmaniac.net behind and turn to the virtual machine described in Appendix A with IP address 172.16.32.131. Before we get started, take a quick look at the basic Nmap syntax by entering Nmap from the command line on your back track machine. You will see immediately that Nmap has a quite few options, but you will use just a few of them for the most part. One of our preferred Nmap option is SS. This runs a stealth TCP scan that determines whether a specific TCP based port is open. Another preferred option is PN, which tells Nmap not to use ping to determine whether a system is running. Instead, it considers all hosts alive. If you are performing internet based penetration tests, you should use this flag, because most networks don't allow internet control message protocol, which is the protocol that ping uses. If you are performing this scan internally, you can probably ignore this flag. Now let's run a quick Nmap scan against our Windows XP machine using both the SS and PN flags. As you can see, Nmap reports a list of open ports along with a description of the associated service for each. For more details, try using the A flag. This option will attempt advanced service enumeration and banner grabbing, which may give you even more details about the target system. For example, here's what we would see if we were to call Nmap with the SS and A flags using our target system. Thank you. Hello everyone, welcome to my lecture, Metasploit Auxiliary Modules. When most people think of Metasploit, exploits come to mind. Exploits are cool, exploits get you sell, and exploits get all the attention. But sometimes you need something more than that. By definition, a Metasploit module that is not an exploit is an auxiliary module, which leaves a lot to the imagination. Auxiliary modules in use. Auxiliary modules are exciting because they can be used in so many ways for so many things. If you can find the perfect auxiliary module, it's easy to modify one suit your specific needs. Anatomy of an auxiliary module. Let's look at the makeup of an auxiliary module in a fun little example not currently in the Metasploit repository. This example will demonstrate how easy it is to offload a great deal of programming to the framework, allowing us to focus on the specifics of a module. Going forward, as you have seen, auxiliary modules can have a wide range of uses. The infrastructure provided by the Metasploit framework can produce a wide array of tools in a very short time. Using Metasploit auxiliary modules, you can scan an IP address range to determine which hosts are alive and which services are running on each host. You can then leverage this information to determine vulnerable services, such as in the WebDAV example, or even log in via brute force on a remote server. Although you can easily create custom auxiliary modules, don't discount the existing auxiliary modules in the framework. These modules may be the exact one-off tool you need. The auxiliary modules provide a wide range of potential additional avenues for a web application. The auxiliary modules offer more than 40 additional checks or attacks that you can perform. In some instances, you may want to brute force a web server to see which servers are listing directories, or you may want to scan the web server to see if it can act as an open proxy and relay traffic out to the internet. Regardless of your needs, the auxiliary modules can provide additional enumeration information, attack vectors, or vulnerabilities. The Social Engineering Toolkit. The Social Engineering Toolkit was developed to coincide with the release of socialengineer.org. This site offers a centralized location for social engineering tutorial and explains terminologies, definitions, and scenarios that can help prepare you for hacking the human mind. The purpose of SET is to fill a gap in the penetration testing community and bring awareness to social engineering attacks, and it has succeeded. SET has been downloaded 1 million times and is now an industry standard for developing social engineering attacks. The toolkit attacks human weaknesses, exploiting curiosity, credibility, avarice, and simple human stupidity. Social engineering attacks are at an all-time high and have always been a large risk for many organizations. Of course, social engineering is nothing new. One person trying to coax another to perform acts that he normally wouldn't do is as old as time itself. Many in the security community believe that social engineering is one of the biggest risks organizations face because it's extremely difficult to protect organizations from being attacked in this way. You might remember the ultra-sophisticated Operation Aurora attack, for example, in which social engineering was used to attack Gmail and other sources of Google data. An attack vector is the avenue used to gain information or access to a system. SET categorizes attacks by attack vector, such as web, email, and USB-based attacks. It uses email, spoofed websites, and other vectors to reach human targets, typically tricking individuals into compromising the target or releasing sensitive information. Naturally, each vector can have a different success rate depending on its target and the communication used. SET also comes pre-built with email and website templates that can be used for the social engineering attacks. SET heavily uses the Metasploit framework because of the social nature of the attacks themselves. Each example in this lecture is coupled with a brief story. Thank you. Hello everyone, welcome to my lecture, Metasploit. In this lecture we will dive deeper into this hacker Swiss army knife that can significantly improve your post-exploitation experience. Metasploit is one of the flagship products in Metasploit and is leveraged as a payload after a vulnerability is exploited. A payload is the information returned to us when we trigger an exploit. For example, when we exploit a weakness in a remote procedure call, trigger the exploit and select Metasploit as the payload, we would be given a Metasploit shell to the system. Metasploit is an extension of the Metasploit framework that allows us to leverage Metasploit functionality and further compromise our target. Some of this functionality includes ways to cover your tracks, reside purely in memory, dump hashes, access operating system, pivot, and much more. Brute forcing MS SQL server. Next, we brute force the server with the framework's MS SQL login module. We select the MS SQL login module at number 1 and point it to the default password list from FastTrack at number 2. Remember, FastTrack is a tool created by one of the authors that leverage multiple attacks, exploits, and the Metasploit framework for payload delivery. One of FastTrack's features is its ability to use a brute forcer to attack and compromise MS SQL automatically. The XP CMD shell. By running MS SQL from the SA account, we can execute the stored procedure XP CMD shell, which lets us interact with the underlying operating system and execute commands. The XP CMD shell is a built-in stored procedure that ships by default with SQL Server. You can call this stored procedure and have it query and execute underlying operating system calls directly with MS SQL. Think of it as a kind of super user command prompt that allows you to run anything you want on the operating system. When we gain access to the SA account, we find that the MS SQL server is generally running with system level permissions, which allows us full access as an administrator to both MS SQL and the machine itself. To get a payload onto the system, we will interact with the XP CMD shell, add a local administrator, and deliver the payload through an executable. David Kennedy and Joshua Track have written a module that can be used to deliver any Metasploit payload through XP CMD shell. After selecting the MSQL payload module and selecting our payload to Meterpreter at number 2, all we need to do is set the standard options before starting our Meterpreter session. We have succeeded in opening a Meterpreter session at number 3 on the target machine. To recap, in the attack described here, we used the MSSQL ping module to guess the MSSQL SA password, which we discovered is password 123. We then leveraged the MSSQL payload module to communicate with MSSQL and upload a Meterpreter shell through MSSQL, and the shell was presented to us, thereby completely compromising the system. Once the Meterpreter shell is presented, we know that the exploit was successful and we can continue with post-exploitation on this system. Basic Meterpreter commands. Having successfully compromised the target and gained a Meterpreter console on the system, we can glean more information with some basic Meterpreter commands. Use the help command at any point for more information on how to use Meterpreter. Capturing a screenshot. Meterpreter's screenshot command will export an image of the active user's desktop and save it to the opt/metasploit3/msf3/ directory. Desktop screen capture offer a great way to learn about a target system. For example, we can see that Mac a free antivirus software is installed and running, which means we will need to be cautious about what we upload to the system. sysinfo. Another command we can specify is sysinfo, which will tell us the platform on which the system is running. As you can see, this system is running Windows XP Service Pack 2. Because SP2 is end of life, we can assume that we can find a ton of holes on this system. Thank you. Hello everyone, welcome to my lecture, The Joy of Exploitation. Exploitation is the pinnacle of many security professionals' careers. The ability to gain full control over a targeted machine is a great feeling, if perhaps a little scary. But even though exploitation techniques have advanced quite a bit over the years, the adoption of various system and network protection has made it increasingly more difficult to succeed with basic exploits. In this lecture, we move into more difficult attack methods, beginning with command line interfaces to the Metasploit framework. Most of the attacks and customization discussed in this lecture will occur in MSF console, MSF encode, and MSF payload. Basic exploitation. The Metasploit framework contains hundreds of modules and it's nearly impossible to remember them all. Running from MSF console will display every module available in the framework, but you can also narrow your search by displaying only specific types of modules as discussed below. MSF saw exploits, MSF saw auxiliary, MSF saw options, MSF saw payloads, MSF saw targets. Info: when the short description of a module provided by the saw and search commands isn't sufficient, use the info command followed by the module name to display all the information, options and targets available for that module. MSF exploit MS08067 NetAPI info: set and unset. All the options for a given Metasploit module must be either set or unset, especially if they are marketed as required or yes. When you enter show options, you will see information that specifies whether a field is required. Use the set command to set an option. Use unset to turn a setting off. The next listing shows the set and unset command in use. Remember, notice that the variables are referenced using uppercase characters. This isn't required, but it is considered good practice. At number 1, we set the target IP address rhost to 192.168.1.155, our target machine. At number 2, we set the target to 3, the Windows XP SP2 English NX that we listed with show targets in MSF show targets on page 62. Running show options at 3 confirms that our settings have been populated as shown in the module options output. Set G and unset G. The set G and unset G commands are used to set or unset a parameter globally within MSF console. Using these commands can save you from having to re-enter the same information repeatedly, particularly in the case of frequently used options that rarely change, such as lhost. Save. Having configured global option with the setg command, use the save command to save your current settings so they will be available next time you run the console. You can enter the save command at any time in Metasploit to save your current place. The location in which the configuration is stored /root/.msf3/config is shown on the screen. If for some reason you need to start over, move or delete this file to revert to the default settings. Exploiting your first machine. With some of the basics behind us and an understanding of how to set variables within MSF console, let's exploit our first machine. To do so, fire up your Windows XP Service Pack 2 and Ubuntu 9.04 virtual machines. We will use Metasploit from within backtrack. If you used the vulnerability scanner discussed previously against your virtual Windows XP SP2 machine, you will have encountered the vulnerability we will exploit in this lecture, the MS08067 exploit. We will begin by finding this vulnerability on our own. As your skills as a penetration tester improve, the discovery of certain open ports will trigger ideas about how you might exploit a particular service. One of the best way to conduct this check is by using nmaps script options within Metasploit. Thank you. Hello everyone, welcome to my lecture, Exploiting Using Client-Side Attacks. Years of focus on defensive network perimeters have drastically shrunk the traditional attack surfaces. When one avenue of attack becomes too difficult to penetrate, attackers can find new and easier methods for attacking their targets. Client-side attacks were the next evolution of attacks after network defenses became more prominent. These attacks target software commonly installed on computers in such programs as web browsers, PDF readers, and Microsoft Office applications. Because these programs are commonly installed on computers out of the box, they are obvious attack vectors for hackers. It It's also common for these applications to be out of date on users' machine because of irregular patching cycles. Metasploit includes a number of built-in client-side exploits, which we will cover in depth in this lecture. If you can bypass all the protective countermeasures a company has in place and infiltrate a network by tricking a user into clicking a malicious link, you have a much better chance of achieving a compromise. Suppose, for example, that you are performing a covert penetration test against a corporate target using social engineering. You decide that sending a phishing email to targeted users will present your best chance of success. You harvest email accounts, names, and phone numbers, browse social networking sites, and create a list of known employees. Your malicious email instructs the email recipients that payroll information needs to be updated. They need to click a link in the email to do this. However, as soon as the user clicks the link, the machine is compromised and you can access the origination's internet network. This scenario is a common technique regularly leveraged in both penetration tests and actual malicious attacks. It is often easier to attack via users than it is to exploit internet facing resources. Most organizations spend a significant amount of money protecting their internet facing systems with tools such as intrusion prevention systems and web application firewalls, while not investing nearly as much in educating their users about social engineering attacks. In March 2011, RSA, a well-known security company, was compromised by an attacker leveraging the same process. A malicious attack sent an extremely targeted email that was crafted specifically for an Adobe Flash zero-day vulnerability. Spear phishing is an attack whereby users are heavily researched and targeted rather than randomly chosen from a company address. In RSA's case, the email targeted a small group of users and was able to compromise RSA's internally connected systems and further penetrate its network. Browser-based exploits. We will focus on browser-based exploits within Metasploit in this lecture. Browser-based exploits are important techniques because in many organizations, users spend more time using their web browsers than using any other applications on their computers. Consider another scenario. We send an email to a small group at an organization with a link that each user will click. The users click the link and their browsers open to our website, which has been specially crafted to exploit a vulnerability in a certain version of Internet Explorer. The user's browser application is susceptible to this exploit and is now compromised simply by users visiting our malicious website. On our end, access would be gained via a payload running within the context of the user who visited the site. Note one important element in this example: if the target user were running as an administrator, the attacker would do the same. Client-side exploits traditionally run with the same permissions and rights as the target they exploit. Often this is a regular user without administrative privileges, so we would need to perform a privilege escalation attack to obtain additional access, and an additional exploit would be necessary to elevate privileges. We could also potentially attack other systems on the network in hopes of gaining administrative level access. In other cases, however, the current user's permission levels are enough to achieve the infiltration. Consider your network situation. Is your important data accessible via user accounts, or is it accessible only to the administrator account? Thank you. Hello everyone, welcome to my lecture, The Social Engineering Toolkit. The Social Engineering Toolkit set was developed to coincide with the release of socialengineer.org. The site offers a centralized location for social engineering tutorials and explains terminologies, definitions, and scenarios and that can help prepare you for hacking the human mind. The purpose of SET is to fill a gap in the penetration testing community and bring awareness to social engineering attacks. And it has succeeded. SET has been downloaded 1 million times and is now an industry standard for deploying social engineering attacks. The toolkit attacks human weaknesses, exploiting curiosity, credibility, avarice, and simple human stupidity. Social engineering attacks are at an all-time high and have always been a large risk for many organizations. Of course, social engineering is nothing new. One person trying to coax another to perform acts that he normally wouldn't do is as old as time itself. Many in the security community believe that social engineering is one of the biggest risks organizations face because it's extremely difficult to protect organizations from being attacked in this way. You might remember the ultra sophisticated Operation Aurora attack, for example, in which social engineering was used to attack Gmail and other sources of Google data. An attack vector is the avenue used to gain information or access to a system. SET categorizes attacks by attack vector, such as web, email, and USB based attacks. It uses email, spoofed websites, and other vectors to reach human targets, typically tricking individuals into compromising the target or releasing sensitive information. Naturally, each vector can have a different success rate depending on its target and the communication used. SET also comes pre-built with email and website templates that can be used for social engineering attacks. SET heavily uses the Metasploit framework. Because of the social nature of the attacks themselves, each example in this lecture is coupled with a brief history. Configuring the social engineering toolkit. By default, in backtrack, SET is located in the pintest/exploit/set/directory. Before you begin, make sure that you are running the latest version of SET. Next, configure your SET configuration file according to what you are attempting to accomplish. We will cover a couple of simple features within the configuration file config/set configure within the root SET directory. When using the SET web-based attack vectors, you can turn on the web attack email flag to perform email phishing in conjunction with the web attack. This flag is turned off by default, which means that you will configure SET and use the web attack vector without the support of email phishing. One of the web-based attacks available in SET is the Java applet attack, which uses self-signed Java applets. By default, this attack uses Microsoft as the publisher name. However, if the Java development kit has been installed, you can turn this option on and sign the applet with whatever name you want. When you turn this flag on, additional options will be available through the interface. The auto detect setting is one of the most important flags and is turned on by default. It tells SET to detect your local IP address automatically and to use that as the address for the reverse connection and web servers. If you are using multiple interfaces or your reverse payload listener is housed at a different location, turn this flag off. When this option is off, SET will allow you to specify multiple scenarios to ensure that the proper IP address scheme is used. For example, in a scenario that includes NAT and port forwarding, these options are reflected within the SET interface. When you use the toolkit, by default it uses a built-in Python web-based server. To optimize performance, set the Apache server flag to on and SET will Apache for the attacks. Those are the basics of the configuration file. As you can see, you can significantly change SET's behavior depending on which flags are set in the tool. Now let's run the tool. Thank you. Hello everyone, Welcome to my lecture, Metasploit Scripting. Metasploit's powerful scripting environment lets you add features or options to Metasploit. In this lecture, you will learn the basics of Metasploit scripting, some useful native calls, and learn how to run these commands from within Metasploit. We will cover two ways to leverage Metasploit scripting. The first method is somewhat outdated but still important because not all scripts have been converted. The second method is nearly identical to the one discussed previously, so we won't cover it in detail in this lecture. Metasploit scripting basics. All Metasploit scripts are located under the framework root under scripts/Metasploit. To show a listing of all scripts, press the tab key in a Metasploit shell, enter run and press tab again. Let's set a simple Metasploit script and then build our own. We will explore the multi-meter inject script that injects Metasploit shells into different processes. To begin, take a look at the script in Metasploit to see what flags and syntax are included. The first option is the M flag at number 1, which automatically sets up a new handler for us on the return connection. We would not need to set this option if we are going to use the same port. Next, we specify the process IDs that we need and the shell into which they will be injected. Metasploit executes in memory only. When we inject into a process, we are injecting Metasploit into the memory space of that process. This allows us to remain stealthily, never reading or writing files to disk, while ultimately having multiple shells available to us. We then set the IP address at number 3 and port number at 4 on the attacking machine to which we want the new Metasploit session to connect. We issue the ps command within Metasploit to get a list of running process. We will inject our new Metasploit shell into the iexplorer.exe at number 1 process. This will spawn a second Metasploit console completely within memory and will never write data to the disk. Let's run the multimeter inject command using some of the switches we reviewed earlier to see if it works. All this output indicates our command was successful and a new Metasploit session has been opened. Now that you will understand what this script can do, let's examine how it works. We will break the script into chunks to help us parse its commands and overall structure. First, variables and definitions are defined and the flags we want to pass to Metasploit are set up. At the beginning of this section of a script, notice that several variables are defined for later use. For example, PID equal to nil at number 1 creates a PID variable, but its value is not set. The next section defines functions that we'll call later. In this example, the function uses at number 1 will be called when the H flag is set. You can call a number of Metasploit functions directly from the Metasploit API. This functionality simplifies certain tasks such as injecting into a new process with the def injection function. The next important element is the host process memory allocated call at number 3, which will allow us to allocate memory space for our Metasploit payload. When we write the memory to our process using host process memory write at number 4 and create a new thread using host process thread.create at number 5. Next, we define the multi-handler that handles the connection based on the selected payload, as shown in boldface in the following output. The default is Metasploit, so the multi-handler will handle Metasploit session unless otherwise specified. The pay equal to client.framework payloads.create call in the following section allows us to create a payload from the Metasploit framework. Because we know this is a Metasploit payload, Metasploit will automatically generate it for us. Thank you. Hello everyone, welcome to my lecture, Creating Your Own Exploits. As a penetration tester, you will frequently encounter applications for which no Metasploit modules are available. In such situation, you can attempt to uncover vulnerabilities in the application and develop your own exploits for them. One of the easiest ways to discover a vulnerability is to fuzz the application. Fuzz testing is the act of sending invalid, unexpected, or malformed random data to an application and monitoring it for exceptions such as crashes. If a vulnerability is found, you can work to develop an exploit for it. Fuzzing is a vast topic, and entire lecture have been delivered on the subject. We will only briefly scratch the surface of fuzzing prior to moving on and developing a working exploit module. In this lecture, we will walk you through the process of identifying a vulnerability via fuzzing and exploit development using the known vulnerability in NetWin Surge Mail 3.8K44 discovered by Meto Memeli and available at http://www.exploitdb.com/exploit/5259. This application has a vulnerability that made it properly handle overly long list commands, resulting in a stack overflow that let an attacker execute code remotely. The art of fuzzing. Before you develop any exploit, you need to determine whether a vulnerability exists in the application. This is where fuzzing comes into play. The following listing shows the code for a simple internet message access protocol, fuzzer. Save this to your root/msf3/module/auxiliary/fuzzer/directory, but be sure to keep your testing modules in a folder separate from the main Metasploit trunk. The fuzzer module begins by importing the IMAP at number 1 and denial of service at number 2 mixins. Including IMAP gives you the required login functionality, and since the goal of the fuzzer is to crash the server, this module results in a denial of service. At number 3, the fuzzer string is set as a randomized string of alphanumeric characters with a maximum length of 1024 bytes. The fuzzer connects and logs into the remote service at number 4, and if it fails to connect and the loop breaks, you have something worth investigating. The lack of response by the server might mean that you have successfully caused an exception in the remote service. At 5, the variable fuzzered is set to the random string generated by the framework, and the malicious request at 6 is built according to the published exploit code by appending the malicious data to the vulnerable list command. If the fuzzer doesn't receive a response from the server, it prints the message "server crashed, no response" and quits. To test your new fuzzer, start up MSF console, load the module and set its option. The fuzzer should now be ready to go. Make sure that your debugger of choice is attached to the surgemail.exe process and start the fuzzer. In this listing, the fuzzer connects and logs into the remote service at number 1 and generates a random string of text at number 2. At 3, the malicious request is sent to the server and the reply is received and displayed at number 4. If the server receives no reply, you receive the notification at number 5 that the server has crashed, which is your cue to check your debugger. If you now check your debugger on the Windows target, you should see that it has paused at the point of the crash. Looking at the crash, we can see that no memory addresses are overwritten and that unfortunately there's nothing really exploitable at first glance. After further tinkering with increasing buffer length, you will find that by sending an even longer string of 11000 bytes, you can override the structure exception handler. Controlling the ACH makes the exploit more reliable because it makes it more versatile. Similarly, the use of an application DLL for a return address makes the exploit portable across operating system versions. Thank you. Hello everyone, welcome to my lecture, Creating Your Own Exploits. As a penetration tester, you will frequently encounter applications for which no Metasploit modules are available. In such situation, you can attempt to uncover vulnerabilities in the application and develop your own exploits for them. One of the easiest ways to discover a vulnerability is to fuzz the application. Fuzz testing is the act of sending invalid, unexpected, or malformed random data to an application and monitoring it for exceptions such as crashes. If a vulnerability is found, you can work to develop an exploit for it. Fuzzing is a vast topic and a lecture have been delivered on the subject. We will only briefly scratch the surface of fuzzing prior to moving on and developing a working exploit module. The art of fuzzing. Before you develop any exploit, you need to determine whether a vulnerability exists in the application. This is where fuzzing comes into play. Controlling the structured exception handler. If you restart the Surge mail service, reattach the debugger to the process, and return the module, you should see the crash that fuzzing found in your debugger. If you are using the immunity debugger, you should be able to see the contents of the SEH chain by selecting View SEH chain. Right click the value, which should be 4 on 4 on 4 on 4 on, and select follow address in stack to display the stack contents, leading to the SEH override in the lower right pane. Now that you know that you can control the SEH chain on the vulnerable Surge mail process with an overly long buffer, it's time to determine the exact length required to overwrite it on the target. As you will recall from our discussion of standalone exploit development, before you can use a return address, you first need to find out where exactly the overwrite occurs. We can modify our fuzzer's code to create a non-repeating random string of characters of a specific length. In this listing, we use rextext.pattern create to generate the non-repeating random string of characters with our fuzzer. Rerunning the fuzzer module now shows that SEH was overwritten on the target with 684E3368. With the SEH overwritten with our random set of characters, we can use pattern offset.rb in opt/metasploits3/msf3/tools to determine exactly where the overwrite occurs by passing the characters of interest followed by the length of the string that was sent to the target. The value 10360 means that the 4 bytes that overwrite SEH are 10361, 10362, 10363, and 10364. We can now change the fuzzer code one last time to verify our findings. As shown, the fuzzer will build the malicious request beginning with 10360 as followed by 4BS to override the SEH, and then 636CS as filter to keep the string length constant at 11,000 bytes. Running the fuzzer against the target again shows that the entire SEH chain is under your complete control. Hopping around SEH restrictions. Following the SEH override, there's very little space for shellcode before the end of the stack. Normally, a pop written set of instructions would be used to reach the next SEH, followed by a short jump forward into the shellcode. We will overcome this limited space restriction by developing an exploit to use as much space as possible for our final payload. At this point, we are done with the fuzzing process and we will move into developing an exploit for the vulnerability that we found. The exploit would be a good candidate for an egg hunter, which is a small segment of shellcode that searches memory for the main payload. However, we will use a different tactic and overwrite ACH with the POP RET and instruction pointer. Once that's overwritten, we will make a short jump backward that requires very few instructions. Next, we will use the space gained in the short jump to execute the target near jump further back into a knob slide and shellcode. Although it's not required, a knob slide is always a good addition to an exploit because it gives you a little room for error should the buffer position change in memory. Thank you. Hello everyone, welcome to my lecture, Windows AV Bypass with Veil. Introduction. We took a quick look at attacking a Linux host. Now let's look at one of the attacking a Windows host. Many people think that if you are running an antivirus and a firewall, that they are generally safe from hacker attacks, but the truth is far from that. Meet Veil, a remote shell payload generator that can bypass many current antivirus programs. One part of penetration testing is getting past that pesky antivirus. Veil is one way that we can accomplish this. Many antivirus programs work by pattern or signature matching. If a program looks like malware that it has been programmed to look for, it catches it. If the malicious file has a signature that AV has not seen before, many will dutifully say that the file is clean and not a threat. If you can change or mask the signature of malware or a remote shell in this case, then most likely AV will allow it to run and the attacker gets a remote connection to the system. Veil, a new payload generator created by security expert and Black Hat USA class instructor Chris Transer, does just that. It takes a standard Metasploit payload and through a Metasploit-like program allows you to create multiple payloads that most likely will bypass antivirus. Installing Veil. Veil was recently added to Kali. If typing Veil at a terminal prompt does not start it, it may not be installed yet. To install, just type apt-get update and apt-get install Veil. Using Veil. The first thing to do is to list the available payload using the list command. The payloads are rated, and since we will be talking a little bit about PowerShell attacks, let's use a PowerShell payload. Just use the use command and the number of the payload. In this tutorial, we will use the PowerShell/virtual alloc payload. Type #use9. This will select the payload and present us with the following. At number 2, we will just use the default values, so just type generate. Then you can choose to use Metasploit standard MS Venom shellcode or choose your own. We will just choose the default ASM Venom. At 3, type 1 and enter. Next, choose the type of shell. We will just use the default, which is reverse TCP. This means that their computer will connect back to us. At number 4, just press enter to accept default shell payload. At number 5, next Veil will ask for the IP address of the host machine that you are using. Enter the IP address of your Kali machine and press enter. At 6, then enter the local port that you will be using. I used to choose 4000. At 7, you will then be asked to enter any MS Venom options that you want to use. We won't be using any, so just press enter to bypass them. And that is it. Veil will then generate our shellcode with the options that we choose. At number 8, now we need to give our created file a name. I choose cute puppy. Okay, cute puppy sounds a little odd, but remember, you want the target to open the file that you are sending them, so a bit of social engineering is required. Getting a remote shell. To create the remote handler, we will be using Metasploit. Number 1. Start the Metasploit framework from the menu or terminal. 2. Now set up the multi-handler using the following screen. Be sure to put in the IP address for your machine and the port that you entered into Veil. They must match exactly. Metasploit will then start the handler and wait for a connection. Now we just need the victim to run the file that we sent them. On the Windows 7 machine, if the file is executed, we will see this on our Kali system, a reverse shell session. Then if we type shell, we see that we do in fact have a complete remote shell. Conclusion. This should help prove that you cannot trust in your firewall and antivirus alone to protect you from online threats. Unfortunately, many times your network security depends on your users and what they allow to run. Instruct your users to never run any programs or open any files that they get in an unsolicited email. Blocking certain file types from entering or leaving your network is also a good idea. And finally, using a network security monitoring system will help track down what happened and what was compromised if the worst does happen. Thank you. Hello everyone, welcome to my lecture, Password Attacks. Microsoft's support for Windows XP, SP3 and Office 2003 will officially end in April 8, 2014. With only 1 year of support left for Microsoft Windows XP, almost 40% of computer users still use it according to some reports. That is a huge number of Windows XP systems that are still being used in business critical positions. Computers do not just store passwords in plain text, but store them in an encrypted form. There are several different ways that computers encrypt their passwords. One of the most secure ways includes salting the password. Basically, this means to use a number and incorporate that into hashing process to ensure that no two passwords are ever the same. Cracking LM passwords online. There are several websites that will allow you to input a Windows LM hashes and it will return the password used. A switch security company called Objective Security has developed a cracking technology that uses rainbow tables on SSD drives. They offer an online demo of their technology that cracks many LM passwords in mere seconds. Not sure what kind of hash you have? There are several different types of hashes. Sometimes you might be able to retrieve a password hash, but might not be able to determine what type it is. Hash ID will identify the type of hash that you provide it. Simply run hash ID and input the hash. The program will check it and return the most likely type of hash that you have along with least likely types. From the Kali menu, Kali Linux /password attacks /offline attacks /hash identifier. Just paste in the hash and hash ID will try to determine what type it is. Looking up hashes in Kali. Looking up hashes manually online is interesting, but it would be better just to do it from within Kali. Well, you can with Find My Hash. Just a note, I really didn't have any luck recovering LM or NT-LM passwords using Find My Hash, which I thought was very odd, as one place it seemed to check is the Objective Security website. Not sure what is going on there, but it had no problem with MD5 hashes. Find My Hash encryption H-hash. Conclusion. In this section, we learned that computers do not store passwords in plain text in the system's security database. The password is encrypted in some way and the resulting encrypted hash is recorded. We also learned that the Windows LM hash is not very secure and can be cracked very easily by using a simple looking up table or rainbow table as it is sometimes called. If the LM hash cannot be found in one of the online databases, then a cracking program is needed. You can turn off LM hashes, but security researchers have found that many network systems and programs still use them for backward capabilities. Pass the hash. In the previous section, we looked at how insecure Windows LM hash based passwords can be, but what about anti-LM based passwords? Windows systems usually store the anti-LM hash right along with LM hash, the anti-LM hash being more secure, and as I mentioned, the LM hash can be turned off. But what a lot of people have asked me is how much longer would it take to access the user account if only the anti-LM hash was available. This is a great question, and the answer is if certain circumstances are met and a certain technique is used, it could take same amount of time. Let me explain. If you can retrieve the LM or anti hashes from a computer, you do not need to crack them. There is really no need. Sometimes you can simply take the hash as is and use it as a token to access the system. This technique is called pass the hash. The pass the hash attack is not new. At the ever popular Black Hat USA conference last year, there was a presentation called Still Passing the Hash 15 years later. That should give you some idea how long this attack has been used. Thank you. Hello everyone, welcome to my lecture, Attacking Hosts. Introduction. We have covered a lot of basic intro, recon and mapping. Now let's look at attacking hosts. Metasploitable 2 is a purposefully vulnerable Linux distribution. What this means is that it has known bugs and vulnerabilities built in one purpose. It is a training platform made to be used with Metasploit to practice and hone your computer security skills in a legal environment. Many think that Linux or Mac OS are much more secure than Windows, but like Windows, if you don't install system patches and updates, they are equally vulnerable. The resource above cover a lot of information on installing and using Metasploitable 2, so I will not spend a lot of time on this topic, but we will go through a couple of exploits using Kali just to see how things work. Installing and using Metasploitable. Metasploitable 2 is available as a virtualware VM. Just download the file, unzip it and open it with VMware Player. It's that simple. If you are using VirtualBox, Rapid7 hosts a video showing the full install of Metasploitable on VirtualBox. A link to the video can found in the resource section above. To log in, enter the name and password shown on the menu. msfadmin/msfadmin. You wouldn't believe how many budding security professionals have asked for the default login credentials for Metasploitable, and they put it right on the login screen. Logging in is pretty anticlimactic. You basically just end up at a text-based terminal prompt. Scanning for targets. One of the first steps that many security testers use is to do an nmap scan to try to determine what ports are open and hopefully even what services are installed on those ports. If we can determine open ports and service program versions, then we may be able to exploit a vulnerability in the service and compromise the machine. Let's take a look at Metasploitable from our Kali box. The first thing to do is to run an nmap scan and see what services are installed. Open a terminal window on your Kali system and type nmap sspn Metasploitable's IP address. Put in the IP address for your Metasploitable machine, which in our case is 192.168.198.145. If you didn't know what IP address your Metasploitable is at, you could always scan a range of addresses by typing something like Nmap SSPN 192.168.198.1.150. The SS switch tells Nmap to perform a stealth scan. The PN tells Nmap not to run a ping scan to see what systems are up. This will show us the open ports and try to enumerate what services are running. That's a lot of open ports. Okay, we definitely have a lot of possible openings. Let's see if we can find out what services are running on them. Let's try the nmap command again, but this time at the A switch, which will perform OS detection and try to determine service versions. Nmap will churn for a while as it tries to detect the actual services running on these ports. In a few minutes, you will see a screen that looks like this. For each port, we see the port number, service type, and even an attempt at the service software versions. We see several of the normal ports are open in the image above. There are also a lot of services running at higher ports. One in particular is an Unreal Internet Relay chat program. Using in tutorials, they cover going after the main port's service first, but I recommend looking at service sitting at higher ports, what is more likely to be patched and up to date. Common core services or a secondary service that was installed and one time and possibly forgotten about. So let's see what we can find out about this Unreal IRC service. In the picture above, we can see the software versions, in this case Unreal IRC 3.2.8.1. Our next step to do a search for vulnerabilities for that software release. Just searching for Unreal 3.2.8.1 exploits in Google should do the trick. But why use Google when we can search with Metasploit? Thank you. Hello everyone, welcome to my lecture, Social Engineering. Introduction. Social engineering is the art of manipulating people to falsely gain their trust in order to get information, access or data from them. Social engineering is in effect hacking humans. Hackers who are experts in social engineering will trick you into helping them or giving them access to your secured systems or areas by pretending to be someone else, someone in need, or even someone in a position of authority. Let's look at some examples. You are coming into work at your secure data center. As you approach the door, a delivery man with his arms full of boxes is also arriving at the door. What do? Without thinking twice, most would open the door for the poor overburdened man and let him in. What if he wasn't a real delivery man and just wanted access to your secure data center? You just let him in. Number 2. You are in your cubicle and are approached by a person wearing a shirt and tie, carrying a clipboard and toolbox. He says that he is performing system upgrades and needs access to your system. It's close to launch time, so it sounds like you are going to get an extended lunch. You ask if you should shut it down, and he responds that he just needs to check a few things first. You get up and head for the cafeteria and just give him access to your system. 3. You are the CEO of a major company. One day you get a package in the mail from a company that you just signed a major deal with. It was the largest deal of your career and was in all the local city newspapers and on all the TV stations. You open it up to find one of the latest tables along with a thank you note from the company thanking you for the business agreement. It has all the bells and whistles and you can't wait to connect it to your executive Wi-Fi network to try it out, which you do. The company never sent you a tablet and you just gave an enterprising social engineer a system connected to your executive network. 4. You get an email from the IT manager at your company. They are installing some new software and need to you install some new drivers. They include the software package as an attachment and give you full directions to install it, which you do. The email wasn't actually from your IT manager, and you just gave a remote hacker complete control of your workstation. They may take advantage of local customs, etiquettes, play of human sympathy, or just try to intimidate an employee to get what they want. They may do none of these direct contact things and simply go through your corporate garbage receptacles, scour for clues of your internal systems by reading job postings or even online tech forums that you use. Or they could hit social media sites pretending to be from a company that you do business with, or pretending to be a headhunter employment agency looking for new talent. These are just a few examples of how a social engineer might try to gain access to or procure information about a target network. There really is no limit to the ways that a talented social engineer might try to twist, deceive, or threaten their way onto your network. Social engineering defense. With that being said, it is imperative to gain your employees to be on the lookout for these types of attacks. Have policies in place to deal with service calls, software updates, and gifts from outside companies. You can teach, instruct, and even leave reminder messages and posters, but employees may still not follow corporate policy. That is why when it comes to social engineering attacks, it is a good idea to manually test to see if your company is truly prepared. In this section, we will look at a couple programs in Kali that corporate security teams can use to test their company's preparedness against these types of attacks. Thank you. Hello everyone, welcome to my lecture, XML and Ajax Introduction. We're assuming that the average readers of this lecture is familiar with the fundamentals of JavaScript and HTML. Both of these technologies are based on standards and protocols that have been around for many years, and there is an unlimited amount of information about how they work and what you can do with them on the internet. However, given the relatively new introduction of Ajax and extensible markup language into the web world, we felt it was a good idea to provide a basic overflow of these two technologies. Ajax is a term that is often considered as being strongly related to XML, as the XML acronym is used as part of the name. That's not always the case. Ajax is a synonym that describes new approaches that have been creeping into web development practices for some time. At its basics, Ajax is a set of technologies for creating interactive web applications that improve the user experience, provide greater usability, and increase their speed. The roots of Ajax were around long before the term was picked up by mainstream web developers in 2005. The core technologies that are widely used today in regards to Ajax were initiated by Microsoft with the development of various remote scripting techniques. The set of technologies that are defined by Ajax are a much better alternative than the traditional remote components such as the IF, RAME, and layer elements defined in dynamic hypertext markup language programming practices. The most basic and essential component of Ajax is the XML HTTP request JavaScript object. This object provides the mechanism for pulling remote content from a server without the need to refresh the page the browser has currently loaded. This object comes in many different flavors depending on the browser that is in use. The XML HTTP request object is designed to be simple and intuitive. For various reasons, the XML HTTP request object is not implemented exactly the same way across all browsers. This is due to the fact that Ajax is a new technology, and although standards are quickly picking up, there are still situations where we need to resolve various browser incompatibilities problems. These problems are usually resolved with the help of Ajax libraries, but we as security researchers often need to use the pure basics. As we established previously in this section, the XML HTTP request object differs depending on the browser version. Microsoft Internet Explorer, for example, requires the use of ActiveX object or even ActiveX object to spawn similar objects to the standard XML HTTP request object. Other browsers may have different ways to do the exact same thing. In particular, response text is used when we retrieve textual documents, HTML pages, binary, and everything else that is not XML. When we need to deal with XML, we use the response XML property, which parses the response text into a DOM object. We have already shown how the response text works, so let's look at the use of response XML. Before providing another example, we must explain the purpose of XML. XML was designed to give semantics rather than structure, as is the case with HTML. XML is a mini language on its own, which does not possess any boundaries. Other standards related to XML are XPath, extensible style sheet language transformation, XML schema definition, Xlink, Xforms, simple object access protocol, XML RPC, and so on. We are not going to cover all of them because the lecture will get quickly out of scope, but you can read about them at www.w3c.org. Both XML and HTML, although different, are composed from the same building blocks that are known as elements or tags. XML and HTML elements are highly structured. They can be represented with a tree structure, which is often referred to as the DOM. In reality, DOM is a set of specifications defined by the World Wide Web Consortium, which define how XML structures are created and what method and properties they need to have. As we established earlier, HTML can also be parsed into a DOM tree. Thank you. Hello everyone, welcome to my lecture. XSS example in web developer website. In this case, the page has been modified using a file located at http://ha.ckers.org/s.js. But if I look at the source of the page, all I see is result 1 to 10 of 1000 for b/script src equal to http://ha.ckers.org/s.js 1 cherishtree.com. Note that in this case the double quote was required due to the search engine's requirements on that particular page. Although it does look superfluous, there is a method to the madness. There may be a number of reasons you cannot go to the JavaScript file directly. Perhaps the website is down, the site uses obfuscation, or the JavaScript is created dynamically. In this case, we can use view generated source to see what that JavaScript function has done to the page. This can be highly useful in dozens of different applications, but most important, it can help you diagnose what your own scripts are doing when they fail. Oftentimes, this can help you debug the simplest errors that are otherwise invisible to the naked eye, because it is hidden behind many layers of JavaScript and CSS obfuscation. Firebug. Earlier in this lecture, we talked about DOM inspector and how useful it can be when examining the inner working of complex web application. In this section, we cover Firebug, another useful Firefox extension that was also built by DOM inspector authors. Firebug is a feature full web application debugger that comes in two flavors, Firebug Lite and the Firebug Mozilla Firefox extension. Firebug Lite is a cross-browser component that can be easily embedded into the application you want to test. It is designed for developers rather than security researchers, and it is not as versatile as the Firefox extension version. However, it could prove to be quite helpful in situations when you need to debug applications in Internet Explorer, Opera, and other browsers that do not support cross-platform installable files for the Firefox Mozilla platform. Firebug Lite. Before using Firebug Lite, you have to embed several script tags inside applications you want to debug. Download Firebug Lite and place it inside a folder on your local system. You have to include the following script tag inside your application pages to enable Firebug. When you need to trace a particular variable in your application, you can use the console object. For example, if we want to trace the change of the variable item in the following loop, we need to use the following code: function bracket var item in document bracket close console.log bracket item. If you press F12, you should see the Firebug console window with a list of each item value. This is much more efficient than the alert method, which can be very irritating, especially in case where we need to list many values. There are some other features, but Firebug Lite is designed to run as a stripped down replacement of the Firebug browser extension. The Firebug browser extension provides an integrated environment from where you can perform complete analysis of the web application that interests you. It has features to explore the DOM structure, modify the HTML code on the fly, trace and debug JavaScript code, and monitor network requests and response like the live HTTP headers extension discussed earlier. Thank you. Hello everyone, welcome to my lecture, Attack API State Scanner. As you can see below, I am correctly identified as being logged into my Gmail account. Like the scan extension function, you can specify your own signatures. For example, to learn more about how to write signature for the scan extension and scan state functions, visit the Attack API homepage at www.gnucitizen.org/projects/attack-api. So far, we have explored some techniques that can be easily performed from Attack API without having much understanding of how they work. The last function that we are going to use reveals the client history. You can see a list of all the sites in the Attack API signature database that I have recently visited. Remember, although attackers can use this technique for malicious purposes, there are cases where it can be used for good. For example, with the same ease, the good guys can scan a large number of users in order to identify individuals that have visited suspicious places. Complete client enumeration with Attack API are shown below. As you can see, the scan states, scan history and scan extensions functions require a callback parameter to get the result back. This is something that you should be careful with. Keep in mind that JavaScript programs are not linear. For that reason, we need to wait for these functions to finish and continue the normal program execution path. This is done with the help of the window.setInterval function. The setInterval function is configured to check the number of the completed variable every second. When this number reaches 3, the collected information is listed on the screen. When the attacker retrieves this information, he or she might want to transport it from the client to some sort of storage point for further investigation. Think about how useful this information can be when profiling different user groups to target a particular audience. This information is not only useful for marketing purposes but also for the attacker's own statistical tools. Taking the data from the client to a server can be a challenge. However, Attack API resolves all browser quirks with a single function. As you can see, the code used here is similar to what we had used, with a few exceptions. The first thing is that we made sure that all of the data is stored as string objects. Array items are serialized as a comma separated list, while objects are exported as uniform. Resources locator queries. You can easily build queries with the a.buildQuery function. Going back to our client enumeration code, you can easily test the transportation mechanism. Just set up netcat in a listening mode like this. With the following line, we spawn port 8888 and set verbosity level to the last notch, collecting gathered information with netcat. Going back to our client enumeration code, you can easily test the transformation mechanism. Just set up the netcat is a listening mode like this. With the following line, we spawn port 8888 and set verbosity level to the last notch. Once you execute the JavaScript code in the Firebug console, you will see that all of the data arrives at netcat as a long URL encoded string. Although you can use any type of encoding, URL encodings are supported by default and you can use them without changing anything. The netcat result should be similar to that shown below. Attacking networks. Being able to extract information from the client represents a small portion of what attackers can do. In many situations, client enumeration is just the beginning of a well-planned attack, which expands across several areas that are discussed throughout this lecture. XSS attacks are not only about client security, because browsers are bridges between the hostile internet and the local network. Attackers can abuse various browser features to locate and attack internal devices. Thank you. Hello everyone, welcome to my lecture, Attacking Networks. Being able to extract information from the client represents a small portion of what attackers can do. In many situations, client enumeration is just the beginning of a well-planned attack, which expands across several areas that are discussed throughout the lecture. XSS attacks are not only about client security, because browsers are bridges between the hostile internet and the local network. Attackers can abuse various browser features to locate and attack internal devices. Let's see how we can attack an internal network with the help of Attack API. Port scanning from a browser is not an exact science. Therefore, you may receive a lot of false positives. To eliminate them, you need to fine-tune the scanning process via the timeout parameters. Now, knowing how to port scan, you can try identifying open ports on your corporate printing by using something similar to the following. The timeout parameter defines how long the port scanner needs to wait for the currently tested port before it flags it as closed. If the victim is going through a proxy in order to access internal web resources, the scan process may fail. However, this kind of setup is very rare. Remember, Firefox and Opera cannot scan port numbers below 80. This is a security feature that both browsers implement successfully. IE does not possess such restrictions. Attack API port sweeping. Attack API is also capable of port scanning a network range. This technique is known as port sweeping and can be accessed via the Attack API sweep port functions. If everything works fine, you will get a result similar to what is shown below. Attack API supports both the start IP, stop IP and the IP/mask notations. In that respect, you can use the following code to scan the cluster range of 10.10.56.0. To perform the network and IP manipulation yourself, you can use several available attack API utilities. Although identifying open ports and live systems is important, we can do more than just a simple port scan. For example, it is possible to launch attacks against internal routers with nothing but a single function call. There are a number of devices with the sole purpose of giving you the best direction on how to move on the internet. The first device is known as the default gateway. If you are a wireless user, this is your wireless router. When you configuring and securing the router, it is possible to set it up so that the administrative interface is also available on the internet facing side. First of all, we call the request CSRF function. This is one of the many request functions available in Attack API that allow you to retrieve or call remote resources. Unlike request XML, which works on resources in the same origin, request CSRF works everywhere, but it is totally blind to the caller. This means that we cannot get the response back. The request CSRF function is called with several parameters. The first one defines the method type, which is post. Next, we define the URL to which we are going to send the payload. Notice that we detect the client's local IP address and then we translate it to the default gateway IP address using the technique discussed earlier in this lecture. Hijacking the browser. Earlier we mentioned that there are two main types of XSS attacks, persistent and non-persistent. We mentioned that persistent attacks are more dangerous because they occur every time the user visits the infected resource. This means that the attacker will have control over the user's browser for a long period of time. On the other hand, non-persistent XSS vectors occur on a single resource and the control is lost as soon as the user leaves the infected page. This means that attackers have a single shot to perform their attack. We also mentioned earlier that it is possible to trick the user into a trap that may grant the attacker the control they need for longer, non-persistent holes. This is done via several hijacking techniques that Attack API offers full support for. Let's see how we can use the library to gain a persistent but unstable control of the victim's browser. Type the following command while you are inside the Attack API interactive page. After a few seconds, you should get a result similar to the if everything worked. You should see Google's front page. You may think that we have been redirected to Google. However, notice that the address bar hasn't changed. This means that we are still inside fasttestinteractive.html, although the view is different. Thank you. Hello everyone, welcome to my lecture, XSS Worms Introduction. Up to this point, we have been discussing cross-site scripting as a hands-on attacker-led method for taking over a browser. As we have illustrated, there are many ways to do this and numerous actions we can perform against a victim, from stealing a cookie to hijacking the entire browser session. While these types of attacks provide a good representation of how XSS is currently being used on the internet, things can get a lot worse. In this lecture, we examine the future of XSS attacks and illustrate the potential for this class of vulnerabilities. Exponential XSS. One of the questions regularly asked by people new to cross-site scripting is, what is the worst thing you can do with XSS? Many of the individual attacks that don't require human interaction with the exploit are all bad individually, but what if we chained those attacks together? Or worse yet, what if we chained them together across a number of sites? What if a single XSS could traverse multiple domains and attack many different sites instead of what if a single XSS could traverse multiple domains and attack many different sites instead of just one? This is the concept behind exponential XSS. Let's assume an attacker finds a single XSS vulnerability on a web page and gets a user to click on that XSS. The single XSS vector begins a series of events, including attempting to add itself to other sites, hacking the user's intranet, sending cookies of any authenticated sessions to a remote site for logging, performing across-site request forgeries, and any number of other activities. Now let's dissect each one of those subcomponents. First, let's consider the concept of trying to jump from one site to another site. There are several ways to do this, depending on the effect the attacker is going for. If a user wants to see the text of a page, there are a number of tools such as anti-domain name server, pinning, or other browser exploits such as the MHTML vulnerability that can be used. If the attacker wants to steal credentials from a site, he or she must find a single reflected or DOM-based XSS vulnerability on the site in question. If the attacker wants to write a worm, it depends greatly on the site in question, but most likely will involve finding a persistent XSS. In the case of an intranet, hacking is often the most important step to gaining enough recon to attack the applications. XSS warhole worm. The above sections focus on a single internet user. However, what if we want to exploit a number of users? We are now talking about a worm. A normal worm on the internet has a very inefficient means of propagation. It must scan the internet looking for vulnerable machines. Once it finds one, the parent node continues to scan the internet while the child rescans the same internet space, making it completely inefficient. The solution to this method of propagation is called a warhole worm. A warhole worm, coined by Nicholas C. Weaver, refers to a statement made by Andy Warhol in 1968. In the future, everyone will be world famous for 15 minutes. A warhole worm or flash worm aims to propagate across the internet in 15 minutes or faster. It is the scariest type of worm, and thus far there have only been a few successful warhole worms in the history of the internet, and only two propagation methods worth discussing in details. The first form of rapid propagation is to pick a pseudo-random number to increase the chance of the discovering more of the internet in a faster amount of time. This was the method used by SQL Slammer worm, which generated an attack increase that doubled each 8.5 seconds. It was considered highly successful and infected approximately 75,000 machines. Thank you. Hello everyone, welcome to my lecture, XSS Worms Introduction. Up to this point, we have been discussing cross-site scripting as a hands-on, attacker-led method for taking over a browser. As we have illustrated, there are many ways to do this and numerous actions we can perform against a victim, from stealing a cookie to hijacking the entire browser session. Will these types of attacks provide a good representation of how XSS is currently being used on the internet? Things can get a lot worse. In this lecture, we examine the future of XSS attacks and illustrate the potential for this class of vulnerabilities. Exponential XSS. One of the questions regularly asked by people new to cross-site scripting is, what is the worst thing you can do with XSS? Many of the individual attacks that don't require human interaction with the exploit are all bad individually, but what if we chained those attacks together? Or worse yet, what if we chained them together across a number of sites? What if a single XSS could traverse multiple domains and attack many different sites instead of. What if a single XSS could traverse multiple domains and attack many different sites instead of just one? This is the concept behind exponential access. Let's assume an attacker finds a single XSS vulnerability on a web page and gets a user to click on that XSS. The single XSS vector begins a series of events, including attempting to add itself to other sites, hacking the user's intranet, sending cookies of any authenticated sessions to a remote site for logging, performing across-site request forgeries, and any number of other activities. Now let's dissect each one of those subcomponents. First, let's consider the concept of trying to jump from one site to another site. There are several ways to do this, depending on the effect the attacker is going for. If a user wants to see the text of a page, there are a number of tools such as anti-domain name server, pinning, or other browser exploits such as the MHTML vulnerability that can be used. If the attacker wants to steal credentials from a site, he or she must find a single reflected or DOM-based XSS vulnerability on the site in question. If the attacker wants to write a worm, it depends greatly on the site in question, but most likely will involve finding a persistent XSS. In the case of an intranet, hacking is often the most important step to gaining enough recon to attack the applications. XSS warhole worm. The above sections focus on a single internet user. However, what if we want to exploit a number of users? We are now talking about a worm. A normal worm on the internet has a very inefficient means of propagation. It must scan the internet looking for vulnerable machines. Once it finds one, the parent node continues to scan the internet while the child rescans the same internet space, making it completely inefficient. The solution to this method of propagation is called a warhole worm. A warhole worm, coined by Nicholas C. Weber, refers to a statement made by Andy Warhol in 1968. In the future, everyone will be world famous for 15 minutes. A warhole worm or flash worm aims to propagate across the internet in 15 minutes or faster. It is the scariest type of worm, and thus far there have only been a few successful warhole worms in the history of the internet, and only two propagation methods worth discussing in details. The first form of rapid propagation is to pick a pseudo-random number to increase the chance of the discovering more of the internet in a faster amount of time. This was the method used by SQL Slammer worm, which generated an attack increase that doubled each 8.5 seconds. It was considered highly successful and infected approximately 75,000 machines. Thank you. Hello everyone, welcome to my lecture. ACA circumventing anti-DNS pinning. Amit Klein published a small email to Bugtrack discussing a way to force the host header using XML HTTP request and throw the flash. His research proves that simply looking at the host header won't do much to stop anti-DNS pinning. Here is an example. XML HTTP request that spoofs the host headers in Internet Explorer 6.0 to evade anti-DNS pinning. The point is the attacker is forcing the user to access the same domain to avoid the same origin policy issues that normally protect websites. As far as the browser is concerned, the user is still contacting the same website, so the browser is allowed to access whatever information the attacker wants. Additional applications of anti-DNS pinning. We have already discussed intranet port scanning as an ideal use for anti-DNS pinning. There is at least one other interesting application for anti-DNS pinning that arose as a result of a vulnerability in Adobe Reader. The Adobe PDF Reader in Firefox and Opera was found to have a document object model based vulnerability where an anchor tag could include JavaScript, thus rendering any website that had a portable document format in it to be vulnerable. There were a number of suggestions submitted to the online community in an effort to control the impact of this vulnerability. One of these ideas was to force a credential to be set by the IP address. Despite the fact there are issues like proxies, it was deemed to be a reasonable risk, at least until anti-DNS pinning was factored into the equation. Here is an example of how simple it is to run JavaScript using the vulnerability against any PDF file. Remember, Adobe has issued a patch for this bug, so it only affects older version of Adobe Reader, but it is still a good example of how anti-DNS pinning can be used to get certain types of protection. Here is the attack scenario. Cat wants to execute and accesses vulnerability on Bob's server against allies. To steal her cookie, Bob has protected the PDF from being directly linked to by an attacker by creating a unique token that protects the PDF from being directly linked to with the malicious anchor tag. Note: remember, both Flash and Java have the potential to create anti-DNS pinning issues of their own. They could potentially have the most interesting control as they can both read binary content, which can give them greater read/write control over raw sockets. IMAP 3. One of the perils of web application security is that it applies to a lot more than just a web server or the web application themselves. Sometimes you can find rare circumstances where two seemingly unrelated technologies can be combined to create an attack vector. In August 2006, Wade Alcorn published a paper on a way to perform an XSS attack against an IMAP 3 server. Before going any further, it's a good idea to understand why other protocols may or may not be affected by this sort of exploit. To do that, it's important to understand a principle in Firefox security model that prohibits communication to certain ports. You will notice that port 220 is missing from this list. In this case, port 220 can cause problems as IMAP 3 can be turned into an XSS exploit. Even if the server is totally hardened and has no dynamic content whatsoever, it can still be exploited if the IMAP 3 server is on the same domain as the intended target. Regardless of the port blocking features in Firefox, other browsers do not port block at all, thus making them potentially vulnerable to similar attacks. In this case, however, the service can be exploited by using a reflected XSS vector. JavaScript has had other negative issues in the past, as documented by Josentov in a 2001 paper on attacking SMTP, NNTP, POP3 and Internet Relay Chat. In these examples, you can use JavaScript and hypertext markup language to force browsers to submit spam on the attacker's behalf or worse. It should be noted that this is not just useful for accessing a remote web server. It can also be useful if you want to run XSS against an intranet, in the case that you need to have read access to a domain that would otherwise be unavailable to the browser because of cross-domain restriction. Thank you.